And good morning and good afternoon, and welcome to the final day of the Research to Practice Transit Symposium. I am one of the co-organizers on this, Chad Writing from Caltrans Division of Rail and Mass Transportation, and I'm looking forward to a great agenda that we have for today. So as you can see here, we have a great agenda. You can find it online at the Symposium website. I've also reproduced it here. We'll begin with a speaker session on using data to provide better transit service, followed by a break, and then followed by a speaker session on climate change resilience, followed by a 30-minute break, and then followed by a panel discussion on new futures in rail. And then we'll close up after a small break with a plenary address and question and answer session from Caltrans Director Topes Amashakin. You can submit questions to me beforehand if you'd like me to ask them. And there will be closing remarks and reflection by Dr. Lily Eleftheriadou, Director of the University of Florida Transportation Institute. A very special thanks to our sponsors, California Department of Transportation, Caltrans, American Public Transportation Association, the University of Florida Transportation Institute, and the T-Score University Transportation Center. Heartfelt thanks to the steering committee, without whose work this would not have been possible. Art Gazzetti, Dave Carroll, David Harris, Louisa Easter, Gabe Matthews, Greg Newmark, Jacob Wasserman, Jacob Yan, Jesus Gomez, Kerry Watkins, Lily Eleftheriadou, Stuart Morey, Noreen McDonald, Chad Writing, Balwinder Tarlok, and Shile Chow. And special thanks to today's participants. We have a great lineup today. And then finally, a special thanks to University of Florida Transportation Institute faculty staff Ondine Wells and Inez Avila Spadoni. They worked tirelessly on the website and with all the revisions that we had to the speaker bios and the symposium schedule. They did a great job and were wonderful to work with. Special thanks to Caltrans employees like Kian Kazipul, Oksana Kambor-Daniliuk, and Jeffrey Ng. They provided a lot of support in the background, monitoring the chat and making sure that everything flowed smoothly. For those of you who are members of the American Institute of Certified Planners, this event is qualified for certification maintenance credit. For more details, please visit the planning.org website. If any of you have panelist questions or are experiencing technical issues, please feel free to contact me at chad.writing@dot.ca.gov. Alternatively, please leave a comment on the YouTube's comment section. Finally, again, if you have any questions or comments, please feel free to contact me. And with that, we are going to stop the beginning phase and move into our first session we have a great lineup of Mary Mohebi, Zach Emmer, and Xiaojian Zhang. So Mary Mohebi presently leads the Transportation Equity Initiative at UFTI. She holds a PhD in Urban and Regional Planning from the University of Cincinnati College of Design, Architecture, Arts, and Planning. As of May 2020, she has been serving on the steering committee of a nationwide health equity initiative, the Planning for Health, Equity, Advocacy, and Leadership, or FEAL. Zach Emmer is a PhD student studying civil and environmental engineering at the University of Washington. He currently works in the Sustainable Transportation Lab on a variety of projects related to population synthesis, transit performance, and electric vehicle adoption. Zach previously worked as a transportation engineer for Transpo Group and helps to contribute to transportation research at the intersection of computer science and civil engineering. And finally, today we have Xiaojian Zhang, who is a PhD student in the Department of Civil and Coastal Engineering at the University of Florida. He received his Bachelor's of Engineering in Transportation Engineering from Southwest Jiaotong University, China in 2022. He is currently working on applying data science on shared mobility research and redesigning demand-responsive paratransit system with optimization and simulation approaches. So we're going to go in that order of Mary, Zach, then Xiaojian. There should be time for a question and answer at the end of this session. So please feel free to put those in the chat or to send those to me at my email address. So without further ado, I turn the time over to Mary Mohebi. Welcome, Mary.
Oh, excuse me, I was muted. I didn't realize that. Good afternoon. I'm Mary Mohebi, the UFTI Transportation Equity Lead. I'm delighted to be here and present our work on behalf of my team. Our project focuses on equity aspect of microtransit services and how microtransit can help fill in the reliability gap of transit services. So the information that I provide here is a part of a bigger project called Evaluation of East Gainesville Microtransit Mobility, sponsored by Florida Department of Transportation. So just to provide you with a bit of background on the case study of this project, in early 2019, the City of Gainesville Regional Transit System, RTS, began to provide microtransit services in East Gainesville. And microtransit routes in East Gainesville are scattered throughout the area and have limited service hours. This figure shows the current transit routes and also the microtransit service soon. Existing microtransit services do not only serve for trips within East Gainesville, but also for connection between the downtown station and other city destinations. So you can see the RTS route in the slide. The majority of RTS routes run 1 per hour, which creates a long waiting time for transit riders. On the other hand, the hours do not reflect the community's need, as the majority of the transit riders in East Gainesville are considered social service workers whose work does not follow traditional 8 to 5 schedule. Therefore, as you can see, there is a potential to fill in such huge gap by microtransit services. Besides this necessity also mentioned in the interviews that we completed by community leaders and public officials that I will touch on later in this presentation. So to provide an image of microtransit ridership, this slide shows data from January to November 2020. And those are data on trip start and end for microtransit pilot program to determine the months of the year when the trips were made and whether the trip was made in the morning, it means 5:30 to 8:30 a.m., or in the evening, 4:30 to 7:30 p.m. And the monthly distribution of trips closely matches with the schedule of the UF and the Alachua County Service System. And as you can see, there is a decline in ridership from the months of March, which can be attributed to the COVID-19 pandemic, as shuttles were running at half the capacity due to social distancing recommendations. And just to give you an idea of where we are in microtransit pickup zone in regard to historically underserved communities, I provide you with, with some information on Black population in the area. The percentage of Black population in the microtransit pickup zone is 72%, compared to the percentage of Black population in the whole city, which is 23.8%, and compared to that for the Alachua County, which is 21%. And also to provide you with an overview of the Gainesville landscape, according to the 5-year estimates from the U.S. Census Bureau American Community Survey, approximately 25% of population within the area served by microtransit live below the poverty line. And one census tract of the identified area has 34.4% of the population below poverty line, compared to the 2019 national poverty rate of 10.5%. The two figures on the right side of the slide show the level of car ownership in microtransit zone at the top, and also the percentage of Black population on the right bottom of the slide. And as it is observable, the area is predominantly resided by communities that can be considered transit-dependent communities. So we use several methods of data collection and analysis to understand the operation of Gainesville Microtransit and also the public perception about the services, from reviewing the existing transit development plans and the data used in preparing those plans, survey and geospatial analysis of possible areas of expansion of the services, and also interviews with community leaders and local officials about existing services and future plan. This presentation is mainly focused on the interviews with community leaders and local officials, and the goal of the interviews were to understand first attitude towards the microtransit pilot program, and second, understanding the role of microtransit program in transportation choices within the community and how those services improve reliability and accessibility for the community. And third, understanding the long-term plan for the services. So we interviewed people in different professional categories, and in sampling the interviewees, three main factors were considered. First of all, interviewees' level of knowledge about microtransit services. Second, their potential connection to East Gainesville communities, and also their previous experiences with grassroots organizations and the city itself. And community leaders were specifically chosen as a way to get an overall perspective on microtransit from a community perspective. So the interviews were conducted between September 2020 and February 2021. And for sure, it was a period that we were in the pandemic, and the COVID-19 pandemic and social distancing policy complicated the data collection process. But we were able to get the data that we wanted using the virtual platforms and also self-administered surveys from microtransit users and non-users. And the table that you see in this slide provides you with a bit of information about the demographic characteristics of the community leaders and public officials that we interviewed for this project. So several coding process and line-by-line data analysis of the semi-structured interviews resulted in extracting 5 main themes related to microtransit pilot program: reliability, efficiency, scheduling, accessibility, and infrastructure. So I share a bit about what interviewees mentioned related to one of the themes, which is central to this presentation: reliability. Just to give you a bit of background about reliability, when there is a lack of reliable transit system, always on-demand services such as microtransit can serve as a connection between transit hubs and riders' necessary locations. So ensuring like a reliable connection from a bus stop to, for example, a healthcare center is essential, particularly when we're working with transit-dependent communities. And also, rather than replacing the larger transit infrastructure, microtransit services can be a critical component of a larger system's sustainability. So reliability in the context of this study was often used in conjunction with efficiency and frequency throughout the interviews. And the interviewees said that the pilot program has the potential to bridge the pervasive efficiency and frequency gap in East Gainesville. So in this context, we see reliability as a combination of efficiency and frequency. And efficiency ensures that citizens can get work shifts or other obligations on time. Therefore, an efficient transportation system saves time and fuel and ultimately result in cost saving, which can help protect funding for infrastructure during budget cuts and fiscal constraint. And frequency help prevent citizens in need of these services from being stranded. And then second, interviewees refer to the general lack of reliable transportation system throughout Gainesville and the reality that such a pronounced absence has isolated the East Gainesville community from available resources and contributed to higher unemployment, higher poverty rate, and less educational attainment for East Gainesville communities compared to the rest of the city. So the finding also regarding the efficiency is also helpful to better understand how reliability of transit services relates to microtransit. As I said, efficiency and reliability were used interchangeably by interview participants. And one recurring suggestion was creating partnership among key employers in the city and public entities to improve efficiency. Specifically, a local official discussed efficiency in balancing microtransit demand from K-12 students with the use of public school buses. So to achieve actual efficiency, they believe the service will need to be merged or another option will need to be created. A significant number, so just to give you a background, a significant number of microtransit users in Gainesville are students. So a partnership between microtransit authorities and the public school system is a necessary next step. And as we all know, merging the system rather than building new infrastructure may also reduce the amount of necessary funding. Besides, interviewees also talked about the current RTS services as being inefficient in terms of time that service demands and the money that is pouring into the system. So this concern overall demonstrates the importance of creating efficient microtransit system, particularly in areas where there is no reliable public transit. So to summarize what we learned from local officials and community leaders' perspective, we found that microtransit has the potential to uplift equity in Gainesville. So we found 3 ways to uplift equity through microtransit and fill in the reliability gap, the existing reliability gap related to transit services. First of all, to create a reliable system that meets the need of communities and address their concern, creating a long-term partnership between the communities and transportation agencies is a necessity that will eventually result in increased trust and also communities' engagement in decision-making related to mobility services. And an effective and inclusive communication approach requires, first of all, accepting the rule of transportation policies in the history of exclusion in the city that we are working, and it's kind of universal in all. It can apply to all cities. And second, talking to communities through their trusted figures. And third, collaborating with community members not as unpaid contributors to the project. So such approach requires conducting inclusive engagement in early phases of each project, which means in planning and budgeting phases very early on in the process, which is very critical because it helps us to identify and mitigate disparate burdens and benefits resulting from transportation projects that we are working on. So in the context of this project and considering that existing mistrust between the government and communities in East Gainesville, the local transit agency needs to, first of all, effectively communicate with different groups in microtransit zone and identify the specific needs, including geographical distribution of services and also time of services that can be beneficial for the community members. And then second, ensure partnership among all interested parties, such as key employers in the area of the impact. And third, conduct an equity analysis to understand what accessibility issues people face in Gainesville and how microtransit can fill in reliability gap from community's perspective. So the second way, so the first way that we found to uplift equity through microtransit services was effective communication. And the second way to uplift equity through microtransit services is networking the entire transportation system, which contributes to creating an equitable and sustainable system that can serve a wide variety of mobility needs. Any microtransit program that launched and administered by a transit agency should work in tandem with other transit services in order to improve the overall mobility in an area. In case of this study, microtransit users get connected to transit hub, but they need to wait a long time to take a bus for other destinations across the metro area. And finally, the last factor, which is very critical in regard to microtransit and also transit itself, is that transit agencies must address exclusionary technological barriers which impact a huge part of the population who do not use banks or do not own a smartphone or internet access. And it's a critical piece of the puzzle. So the table in this slide shows the results of one questions related to a survey we conducted by Microtransit users as participants. As you can see, the majority of users who responded to our survey reserved their trip by calling the dispatcher. So this result may indicate that Microtransit users do not have access to other means of reserving services, and lack of access to internet, smartphone, and other complications related to reserving Microtransit services were also frequently mentioned during interviews by community leaders and local officials. And it's a very critical issue that we face. And the longer transit agencies delay in addressing these issues, the more complicated the solutions will become as technology grows more enmeshed in everyday transit interaction that we have. So as a final word, the step mentioned in the last two slides provided an incredible opportunity for local transit agency to make sustainable and affordable solutions for the existing and reliable transportation system. And in the context of this research, existing inequities adversely influence the life of community members in East Gainesville and undermine the social cohesion for the whole metropolitan area in the long term. So equity advancing practices such as, for example, advocacy partnership and creating a culture of fairness are some of the required steps for any transit agency to better understand the community they serve, which is the first step that we should take for the betterment of the services. Thank you very much for your interest in our project. If you have any questions, just feel free to mention it at the end of this presentation or send me an email. I welcome any question that you may have. Thank you, Chad. I will hand it to you.
Thank you very much, Mary. Really interesting insight into the equity work and the innovative microtransit that's going on in East Gainesville. Next, we'll be hearing from Zach Emmer. Zach, turn the time over to you.
Thank you. Let me share real quick. Okay, so yeah, thank you for having me. And the title of my presentation is Measurement and Classification of Transit Delays Using GTFS-RT Data. My name's Zach. I worked on this project with Andeshay Ranjbari and Don McKenzie. We're from the University of Washington. And so this study basically came about where we were trying to locate places in the Seattle region with large magnitude of intermodal conflicts between metro buses and other roadway users. So delivery vehicles, pedestrians crossing the crosswalk, Ubers parked in the bike lane, things like this. We collaborated with local agencies, so Sound Transit and King County Metro were collaborators on the project, along with some local businesses, Amazon and Uber, and then of course that's the University of Washington. And what we wanted to do was understand the places where buses were delayed by other modes and try to propose and test some treatments so that we could do a pilot study in preventing those intermodal conflicts and then see how it turned out. But this sort of led to this big question of where we can prioritize our observational resources in terms of putting people on street corners and looking for delays because it's a big city and you have to pick out very specific corridors. And so we went through this process of selecting corridors based on the input of our stakeholders, Sound Transit, King County, where they thought there might be lots of conflicts, as well as a public survey. And then we did this data collection, which I'm going to talk about in this presentation and some of the findings from that data. And the general goal was to do a hotspot analysis and figure out where transit was performing poorly in the network. And so it turns out this is a huge question, right? Like, how do we quantify transit performance? Well, there's level of service. You can look at the on-time performance if you want to measure reliability, or you can look at the individual instances of delay, which is what we ended up doing. But of course, whatever metric you use, you're going to have to inform with some sort of data. And after talking to our stakeholders and looking through what was available, we settled on using the GTFS-RT feed for the King County Metro network, which is supplied by one bus away. More on that later. We considered using onboard video for part of the study, but it was a bit prohibitive working with the video files. And then we also performed some in-person data collection. And so, yeah, this is just from the TCQSM. I'll come back to this in just a second, but ultimately the selection of the performance measure depends not only on what you're trying to figure out and the stakeholders, but the data that you have available. And so high-level goals of this project. We want to quantify transit delays using the King County Metro GTFS RT feed. And we collected and archived the data from that feed for a 1-year study period. And we performed this analysis basically on a segment-by-segment basis throughout the King County Metro network in Seattle, Washington. And it's outlined for this presentation. So coming back to this chart from the TCQSM, we wanted to target our metrics towards things that could measure efficiency of the system and sort of how effective is it per quantity of resource spent, things like passengers per hour, and also the reliability of the system. So how consistent is the system, not necessarily how effectively does it move people or provide utility. And because we were looking at those individual instances of like intermodal conflict between buses and other users, we wanted to use delay and sort of these measures related to the system speed to measure how much delay buses accumulate and how that affects reliability. And so we also performed these two classifications, the first being classifications of delay, being stochastic delays, which is from this Wessel and Wiedener, sort of these unpredictable, non-recurring random events, things like large amount of people crossing the crosswalk in front of a bus, collision causing lots of traffic, sort of these unplanned events. And these could be compensated for with schedule padding in our treatment phase. And this is just sort of adding flex time to the schedules, or through these systematic delays, which would be more semi-predictable, recurring things, mostly congestion. And these could be targeted for improvement with proactive things like priority lanes or basically changing the signal priority to allow buses to get through certain problem corridors faster. And so then the question became, so how do we collect data on these delays? And as I mentioned before, we used AVL and GTFS, or we used GTFS data, which is really just repackaged automated vehicle location data. And this is collected by reading the onboard sensors, things like the GPS and the odometer readings per bus, and it gets sent to sort of a central dispatch, who then uploads in this general transit feed specification real-time format so that individual users can download that data and perform their analyses. And just a little bit more about the GTFS RT standard. So many people are familiar with the GTFS format, very widely adopted sort of format for sharing transit scheduling data. The RT, the real-time portion of that standard, just adds real-time vehicle updates. It's usually in this real-time.proto file, although many agencies also upload their data to a web API, which is what we used for this study, and that's the One Bus Away API in the case of King County Metro. So, okay, there's also lots of concerns with GTFS RT, like it's a developing standard, it's very fluid. It recently went from 1.0 to 2.0, and sort of this ongoing development of what is optional and what is required to be posted in a GTFS RT feed. And there's lots of interesting work on that, as well as validating GTFS RT feeds from Sean Parpeau. And I would recommend looking into their work if you want to understand some of the problems with GTFS RT. That being said, it's just this really exciting opportunity for open source transit analysis. And so here's a tool in the King County Metro region, which just sort of shows the locations of all the buses in the network and updates, and you can track where they're at any point in time. So high-level picture of our case study. So we collected our data from the One Bus Away API, quantify those delays based on schedule deviation, coordinates, and odometer readings. I'll get into that in a second. And then we assigned those to segments and did our analysis. So here is the component specification for our scraping process. We're basically collecting from the One Bus Away API, storing in a relational database. And then we also have this summarizer, which we're using to basically provide an interface for our archived data in terms of an interactive web tool. The idea being that we could easily extend this to other feeds and provide sort of an interactive look at how transit is performing and generalize that to other feeds besides just the King County Metro feed. And so the parameters that we're collecting from the One Bus Away API include some things like trip ID, vehicle ID, just tracking which route and which bus is being delayed, as well as the schedule deviation, which is this measure of schedule adherence. It's sort of the number of seconds that a bus is on, ahead of, or behind schedule. The last known distance along trip, which tells you how far along the trip in terms of distance the bus has traveled, GPS coordinates, and then the last time that these were recorded. So just to elaborate on schedule deviation just a touch more, you could have a bus, it's this cumulative measure of delay. So you could have a bus which leaves on time, perhaps there's a collision which delays it, and that would be a 60-second delay that was unplanned for, and then you have a positive schedule deviation of 60 seconds. And then it can also be negative in case the bus speeds up for some sort of unplanned reason. And so this bus is ultimately arriving 10 seconds early, which would be a negative schedule deviation. Okay, so these are the delay metrics that we calculated from the collected parameters. The first is pace. So we collected the location time and distance of the bus. So this is just time over distance between two consecutive bus locations. And then the way we calculate the total delay between two bus locations is we take the 95th percentile pace for that segment the bus is traversing. We subtract the current pace that the bus is experiencing, and then we multiply it by the distance it traveled. So that just gives us sort of this difference between the free flow speed of the segment and what is currently being experienced by the bus in terms of seconds of delay. Then we also include the stochastic delay, which we calculate from the schedule deviation parameter. And this sort of tells us what portion of that total delay was unexpected by the current bus schedule. And then, of course, we calculate systematic delay as the subtraction of the stochastic delay from the total delay. So this is things that are recurring events that are maybe slowing the bus down relative to the free flow speed, but are accounted for in the schedule. And then we also face this problem of how do you assign these delays to individual segments. And the way we did that is we basically took the Tiger shape files, which are roadway segments provided by the American Community Survey. And we broke those apart, buffered the GTFS locations of the routes in the King County Metro network, and then figured out exactly which segments buses are traversing. And then we assigned our delays to only segments that the bus which experienced that delay traverses. Okay, so this is the case study region. I'm just going to talk about some main components. So our north-south highways are State Route 99, I-5, and Interstate 405. Our east-west highways are I-90 and SR 520. And then we have kind of three central business districts in the region, being Bellevue. The University of Washington has a pretty big impact on traffic, as well as the Seattle Central Business District. And there's two ways we looked at the results. The first was as individual vehicle trajectories. So trying to figure out, we did in-person observation and trying to see whether we can see those delays that we observed in person in the GTFS RT data. And then we also just aggregated our delays to the entire network. So just a summary of our data collection. This is a heat map showing locations in the network where we collected data. One of the things to keep in mind is that places where buses travel more slowly, like here we're showing the downtown area, collect more data because it's updated every 30 seconds. And if a bus is traveling more slowly, it will accumulate more data in these places where it's traveling slowly. We had a median stochastic delay of negative 19 seconds, indicating that on average buses speed up, have an unplanned speed up in the network. This could be due to schedule planning or schedule padding. I'll talk about that more in a second. And this is a distribution of the individual types of delays. So you can see our total delay by definition, right? We made it the 95th percentile, so 95% of the time the bus is going to have a positive total delay. One of the interesting things we noted was that the schedule deviation parameter is updated in magnitudes greater than 15 seconds. So we have this sort of normal distribution, but with just a gap in the middle because it gets rounded down. Yeah, and then I guess just kind of interesting was this chart showing how the ratio of the mean to the 95th percentile speed changes throughout the time of day. So you can see the 8 a.m., 3 p.m. peaks where the performance is low. Okay, and so looking at the individual vehicle trajectory results, this is just kind of showing you what I'm talking about. We have a study corridor here, and we're looking at an individual bus which was tracked coming along through the study corridor and continuing on its trip. And then places where the bus travels more slowly, it accumulates more data. Maybe it gets stopped at an intersection or it makes a stop. And so there's going to be more data in these locations, which may be a good thing because we are looking at delays, which are going to slow the bus down, right? Okay, so explaining what's going on in these graphs, each one of these is a distribution of travel times for one of our study corridors. The blue line is the median travel time, and the red line are travel times of buses which we observed in person as having a source of delay, whether that's stopping to put a bike on the bike rack or a pedestrian crossing in front of the bus, things like this. So what we would expect is for all of the red lines, the delayed buses to fall to the right of the median, or we can look at that to see empirically whether there was any delays. And we found that 60% of the time, the delayed trips did have a travel time greater than the median, but this isn't really persuasive, 60% of the time. And there's lots of problems with this approach, like calculating travel time depends on the resolution of the bus feed. So if a bus is tracked sort of in the middle of the corridor and then the next track position is out of the corridor, it's difficult to calculate the travel time for a specific corridor. And then, of course, delays are of different magnitudes. Here, we're treating them as a binary. Was it delayed or was it not? But some delays may be 5 seconds, others may be a minute. And so it's hard to say. So we also looked at them like this. And this is basically showing the d-mean schedule deviation. So starting from 0. And each of these is the trajectory of one of our buses, which was delayed. And at this time of interference 0, skipped to the next point that the bus was tracked, we would expect there to be an upward jump in the scheduled deviation because the bus was delayed, right? But it turns out that in aggregate, when we fit this curve to all of the scheduled deviations, there was a downward jump. So this, again, not very convincing. We can say that if these are systematic delays rather than stochastic delays, then perhaps they're covered by schedule padding. But I think in reality, we need more data to say anything definitively. One of the challenges of working with these individual trajectories was that the intermodal conflicts are very sparse, and so it was hard to collect a lot of data for those. So yeah, like I'm saying, it's very difficult to track the individual effects on the GTFS-RT feed of those delays. But the question is, in aggregate, can the delays tell us anything about the network? Because we want to perform this hotspot analysis. And so the answer is yes. First, looking at pace, you can clearly see the downtown Seattle district, the University of Washington, and the Central Business District in Bellevue, where buses travel more slowly. But of course, this is only calculating maybe efficiency because it's showing how quickly the buses are traveling. If the bus is scheduled to be traveling more slowly, then it's not going to affect the reliability at all. And so that's why we have this measure of stochastic delay, and this shows it's a little bit more random, mixed as we would expect, right? But the point being that you can look at locations where there's highly variable travel times, or the bus gets off schedule more frequently or by a larger magnitude. And one of the interesting findings here was that on these highway segments, this I-5, SR520, and I-90, buses experienced very large speed ups. And so we think that's because there's not many stops here. It gets bundled in with the slowdowns once the bus leaves the highway. And so in that way, maybe a bus experience, it gets far ahead of schedule while traveling on the highway, but then once entering surface streets, it slows back down and comes out to a net 0, or I suppose net negative 19-second schedule deviation. And then lastly, we have the systematic delay where you can kind of see corridors more clearly, where the system may be highly efficient highways or highly inefficient. And this just provides a better screening tool for where we might implement those efficiency improvements like transit signal priority or bus lanes. So lastly, we had this TransitViz interactive web tool. We named it affectionately TransitViz. And this basically provides an interface with our archived data. And so we have additional performance metrics, things like median speed, and some cool filters that can be applied, changed by time of day, what route. And this is updated once every 24 hours, but it's just a prototype for now. And we're looking into making it not just sort of a 24-hour update, but real time. So it constantly updates the performance. So in conclusion, I think one of the main takeaways for us from this study and in terms of research meets practice is that when transit agencies provide open source data, it really allows us to make, from a research perspective, it allows us to make tools that are more generalizable and really supports the standardization of tools between networks. In this study in particular, we found GTFS-RT was very capable of identifying network hotspots, but maybe not necessarily these individual instances of delay. The trends sort of show up in aggregate rather than at the individual trip level. And then in terms of future work, we're looking into investigating further the relationship between these recorded delays. So we're collecting more in-person data, and we're trying to interpolate between bus locations to get better measures of travel time. And better inform our metrics. And then, of course, in the future, I think everyone should continue developing tools based on GTFS-RT. There's lots of opportunities to incorporate additional transit performance metrics, get into things like accessibility. We've just really scratched the surface here. So thank you very much. Happy to take questions at the end, and I'll turn it back to Chad. Thank you.
Thank you very much, Zach. I really thought it was interesting how you mentioned the individual delay versus systematic delay versus stochastic delay, and some of the ways that that can interact in the data there. And also, obviously, the importance of GTFS real-time as being an open data standard. So great. Thank you very much, Zach. And now we'll move on to Xiaojian Chang, who will have our final presentation of this session.
Okay, thank you.
Xiaojian.
Okay. So I will share my screen. Okay. Okay, so thank you. So hello everyone. So I'm Xiaojian. So today I'm going to share you our research topic of optimizing demand responsive paratransit operations. And the outline for my presentation is, I will first quickly go through the background of paratransit, and then I will introduce the methodology framework of our study. And then I will introduce our case study for this research and show some key findings. And finally, I will present some major takeaways of our research. So let's go into the background. So nowadays, transportation has played an important role in providing people's access to healthcare facility. So as shown in this figure, for the past 2 decades, there is an evident trend that more and more Americans are experiencing delays in non-emergency medical care due to a lack of transportation means. And more recently, 5.8 million Americans delayed medical care in 2017 because they did not have enough transportation. And those who missed healthcare appointments experienced adverse health outcomes, and missed or canceled appointments could highly impact the arrangement and working efficiency of healthcare providers. People who usually have transportation barriers to healthcare facility are often transportation disadvantaged. And some studies found that people's accessibility to healthcare could be disproportionately across different population groups. For example, those people are often older, for example, over age 65, have lower incomes, have chronic illness and disabilities, have low education attainment, have no access to personal vehicles, have limited or even no health insurance. And researchers also found that individuals carrying the highest burden of disease face the greatest transportation barriers, and the people of color and the female are more likely to have transportation barriers to healthcare. So for decades, transit agencies have provided a more flexible transportation option, namely the paratransit services, to address these issues. So compared with the fixed road transit, paratransit system is more flexible in both scheduling and routing. However, current paratransit system often suffers from long waiting times, low operation frequencies, and high cost. These factors, may highly restrict the people's access to healthcare. So in recent years, ride-sourcing companies such as Uber and Lyft have emerged as important providers of non-emergency medical transportation services. And many transit agencies are developing Uber-like public and on-demand options for non-emergency medical transportation, where customers can schedule a round trip from their home to a healthcare facility with preferred pickup and drop-off times and locations, hours or days before an appointment. However, how to design an efficient and economic paratransit system to provide such demand-responsive service is still an unsolved problem. So there are several underlying problems. For example, ride-sourcing and paratransit have different goals. As ride-sourcing operators want to maximize profits, however, paratransit operators need more efficient operations. And paratransit service needs specific vehicles. For example, they usually need specific vehicles with a wheelchair. So these differences reach to a research question that how to integrate with ride-sourcing system and paratransit system. So when we designed the demand-responsive paratransit, we should consider both the characteristics from resourcing services and traditional paratransit services. So in our study, we want to address the trade-off between the operating time, which is closely related to operating cost of transit operators, and the traveler's waiting time, which is closely related to operating efficiency and the user experience. So the first research objective is to minimize the total operating time for operators, and the second one is to minimize the total operating time for users. So in this study, we developed an Uber-like door-to-door service system for providing non-emergency medical transportation. So as you can see in this diagram, each vehicle departs at the depot to pick up and drop off a set of customers as required by their scheduled times and locations, and then returns to the depot after serving all the requests. So next part, I will talk about the methodology of our study. So paratransit system has some basic parameters. For example, it has a fixed depot, and the departure and the return times for each vehicle are not necessarily the same. And usually, there will be an associated service time at each pickup and the drop-off location for boarding or alighting. And all customers need to book their trips by calling or making a request online in advance, usually at least 1 hour before their desired pickup time. And also, the working hours are divided into intervals of equal length. So before the start of each working time interval, a group of vehicles are selected from the fleet to form a group to serve the request within this time interval. And the size of the group is dependent on the number of requests received in this interval. And we also have some basic assumptions for our study. So first, the service is only available by booking at least 1 hour in advance, and customers should allow a time window at each location. And we assume only one customer is served for each trip. And finally, all vehicles meet the requirements of Americans with Disabilities Act. And I will first talk about the operator model. So from the operator's perspective, operators should serve the customers in the most cost-effective way, which means they should try to lower the operating cost, and they should ensure that each customer can arrive at the hospitals on time for their appointments. And also they should make sure that each customer can be picked up from the hospital no later than the scheduled time. So before we come to the model, here I want to introduce two important definitions here. So the first one is the inbound trip. As you can see in this diagram, inbound trip means a trip from home to a healthcare facility. And outbound trip, which means a trip from a healthcare facility to home. Since the goal of operators is to minimize the travel cost, the objective function here is to minimize the total travel time for all vehicles, which is closely related to travel cost. So this problem is pretty similar to traditional vehicle routing problems such as the dial-a-ride problem. So most of the constraints here are roughly the same in dial-a-ride problem. So for example, we have some constraints related to customers like every customer can only be visited once, and each customer is picked up before dropped off, and some vehicle-related constraints. For example, each vehicle starts at the initial depot and finish at the final depot. And also we have load and time constraints for successive nodes, and each node has a specific time window, and each vehicle has a capacity limit. And the next part is the user model. So, user experience is mostly dependent on the difference between the scheduled time and the actual time of inbound trips and the pickup times of outbound trips. So this is because people care more about if they can catch the appointment and if they can be picked up on time in hospitals. And additionally, it's intuitive that a late arrival is less preferable than early arrival because late arrival usually means missing the appointment. So from the user's perspective, the goal is to minimize the sum of those differences between scheduled and actual time and adjust the schedule away from late arrivals. So And the user model also includes the constraints we introduced in the operator model. And in the next part, I will introduce the case study. So we have access to demand responsive trip data for medical and nutritional purpose in 2019. So the data set has some attributions like trip purpose, trip cost, scheduled pickup and drop-off times, the manually recorded odometer readings and the timestamps at pickup and drop-off locations, and the latitude and longitude of trip origins and destinations. So after data cleaning, we have more than 22,000 observations. So this is a research area. So most of trips took place in Anson County in North Carolina. And we also did some spatial and temporal analysis. So we plot the trip generations and attractions. So we can see here they have an almost similar pattern. And also from the census block level, the pattern is pretty similar. And we also generate the trip distributions by pickup and drop-off time on an hourly basis. So we can say more than half of trips started and ended during 6 a.m. to 12 p.m. and nearly all afternoon trips took place at Anson. And we also did some statistical analysis. So here on the left side, it's the pickup and drop-off wait time. And on the right side, it's a number of trips grouped by month and the trip purpose. So for all months, the average pickup and drop-off wait time are negative. So this finding informs us that the schedule of the current paratransit system in Anson is not efficient, so that should be redesigned. So, we conduct a computational experiment. So we select trips that took place on January 3rd for experiment. So the total number of trips is 58. And in our experiment, we set the fleet size at 5. We assume all vehicles are identical with 7 seats. We set the working time interval as 1 hour. So all customers must book their trips at least 1 hour in advance. And also we set the length of time window at 30 minutes. And we also use the commercial optimization solver called Groby to solve our problem. And I will show you the results. So this table is the summary of 2 models for all cases. So as we can see, in many cases, user model has slightly more variables and constraints than operator model. And also we found that when the number of trips is smaller than 10, both models can be solved in seconds. However, as the number of trips increases, solving operator model becomes more time consuming, but it still takes less than 1 minute. However, we can say the most difficult case is the period 12 p.m. to 1 p.m. With 12 trips. So a possible explanation is that this period has the greatest number of orders, and compared to other periods, the spatial and temporal distributions of orders in this period are more uneven. So this would largely increases the CPU computing time. And this table shows the results of user and operator model. So for a better understanding of the trade-off involved in these 2 models, we compute the objective of user model using the solution yielded by the operator model and vice versa. So for convenience, we use A_B to denote the value computed by the objective function of model A and the solution from model B. So here, UM_rho, UM_UM, and UM_OM in this table are the value for objective of user model evaluated as the raw data, the solution yielded by the user model and operator model, respectively. And the value in the bracket is the time difference reduced compared with the raw data. So from this table, we can say the user model can significantly improve the service performance. The total time difference is reduced from more than 2,000 minutes to just 53 minutes. So the improvement is more than 97%. And also, we can say the routing result of the operator model also lower the total time difference, but the improvement is negligible compared with the user model. And based on the results, we found out that in some cases, the time difference yielded by the operator model is even worse than that from the raw data. So as you can see in this table, the values in the bracket are negative, which means the total time difference is increased. So a possible explanation is that the operating policy of operator model is to ensure all customers reach and leave hospitals on time while minimizing the total operating time. So in order to lower the total operating time, fewer vehicles will be used and more ride sharing will occur. So this will result in an increase in customers in vehicle time and hence an increase in the time difference. And for the last two columns in this table, we use V and score UM and V and score OM to represent the number of vehicles used as a solution from user model and the operator model. So we found that the user model generally uses more vehicles than the operator model. So it's quite reasonable because using fewer vehicles will reduce the total operating time and lead to more cost-effective operations of the paratransit system. And lastly, there is an interesting finding that the user model does not sacrifice much more on the total vehicle operating time, even though its objective is to minimize the total time difference. So as we can see in this table, when we compute the objective of the operator model at the routing solution from the user model, the total vehicle operating time is 5,019 minutes, which is only 23% more than that of the operator model. So this means the user model does not sacrifice much on the vehicle operating time, but provides a better service. So the next part is a conclusion. So in this study, we designed a novel Uber-like paratransit system from both the operators and the users' perspectives, and solved it by a mathematical modeling approach. And because the user model can improve the user experience without sacrificing so much vehicle operating time and also improving users' experience, it's very important to transit agencies. So it's advisable for key stakeholders like cities and transit agencies to apply the proposed user model when planning new demand-responsive paratransit system. And the most important takeaway from our study is user model does not sacrifice operating efficiency a lot, but provides much more better service to riders. And this study still has some limitations. So for example, we only used trips from a single day as a case study. So in the future, multiple days should be tested. And we will conduct the sensitivity analysis in the future study. And here are the references for this study and the acknowledgement. And okay, thank you. That's all my presentation.
Thank you very much, Xiaojian, for your great presentation about the pilot project that you had in Anson County, North Carolina. Thank you again to Zach Ammer about his presentation that really focuses a lot on being able to use real-time data for figuring out transit delay. And then thanks a lot to Mary for the case study of East Gainesville. A lot of really great insight on how to use data in making transit decisions. One thing that kept going through my mind was the thing I was taught earlier in my planning career about the difference between good delay and bad delay, and how some delay shows that some areas are very popular destinations, whereas some delay is caused by road design or by incidents that happen. So a lot of really deep insight that can be gained from these talks. Thank you so much again for your time. We're going to go on a 15-minute break, and we will be back at 10:15 Pacific, 1:15 Eastern Time with a session on climate change resilience. So again, thank you very much, Xiaojian, Zach, and Mary, and we will go on break.
Afternoon, and thank you everyone for coming today. My name is Stuart Morey. I'm with the Caltrans Division of Research, and today's panel will focus on greenhouse gas reduction, resiliency, in infrastructure, and other climate change topics. These presentations will focus on cutting-edge research, stakeholder involvement, and what agencies have done with community-based organizations. During the presentation, please feel free to send your questions to Chad at his email below. I'm pleased to introduce 4 speakers today. First of all, we have Chang Feng and Norman Wong. Chang Feng is the founding co-chair of the Resilient Design Committee with the American Institute of Architects in California. Norman is a principal engineer with the Bay Area Rapid Transit Agency. He has over 10 years of experience in addressing environmental and sustainability issues. Please welcome Chung and Norm.
Good morning. Thank you, Stuart. Can you see my screen?
We can't see your screen yet.
You can't? Okay. Can you see my screen?
Yes.
Can you see PowerPoint?
Yep.
Okay.
You're good to go.
Good. Thank you, Stuart, and thank you for the audience who join us virtually around the country. When we think about climate resiliency, we probably all think about at different scales: global, national, regional, and local. I would like to share my perspective on why we should invest in a local or in a regional strategy as far as transportation sector is concerned. Take BART as an example. It is a heavy rail system, serves the San Francisco Bay Area region. We see regional strategy can offer multi-dimensional benefit. Due to time limitation of this session, I just want to highlight 3 critical reasons and have Norman Wong to continue to discuss the actual work that we'll perform at BART in the context of a regional strategy. So, first of all, a regional approach could have shared a vision that builds on regional consensus. For example, BCDC, Bay Conservation and Development Council, which is a state agency, but it has a function and ability relate to the regional stakeholders and promoting these regional initiatives. Recently, we have a Bay Adapt, which lead to the creation of a joint platform for the region to act on resiliency work in adapting sea level rise as a whole. And that initiative helped to define how to protect vulnerable communities and develop holistic adaptation plan, and where we see transportation resiliency can be organically integrated. So that's the principle or reason 1. In a similar fashion, a few years ago, Bay Area also have launched an NGO initiative called Resilient by Design, which is funded by Rockefeller Foundation and as an endowment. That work has led to the possibility of having different sectors of the region through careful study of the sea level rise impact to the region as a whole and impact to different sectors. That effort can lead to the sectors agree on and are committed to collective responsibilities to the region. such as transportation sector's role. So this is just a quick overview of how a region can look at the sea level rise as a singular scenarios, has a different scale of impact to the entire region. And you can see perhaps these indentation levels around the bay. And the sites that has different impacts to different sectors can be impact to highway system, bridge system, and rail systems. One of the sites that was highlighted as rectangular shape are the area that converges many issues, including heavy rail like BARTs in the area. So to lead the research-based and collective responsibilities defined by careful and multi-stakeholder approach, it will help the transit sectors and transportation sectors to understand their mission in adaptation. And the third principle benefit or reasoning that a regional approach is critical for transit is we need more interjurisdictional design innovations. We can talk about policy and governance all year long. At some point, rubber meets the road. The design becomes the key step, delivers the actual results. It could be a successful dream come to true for the community, or it could be nightmare if we don't treat them right, if we don't develop a design solution right. So a quick example of what that means of interjurisdictional and interdisciplinary design innovations. On the left, you see a waterway runs through a city, and parallel with it is a rail transit. And you see many access points on the floor, which is, I believe, access to a signaling system of the rail. And you also see the other side of waterway with sunken or depressed a public plaza or river walk type of space, which encompasses about 20 feet deep and 2 city blocks long. And you see that combination allows the capacity of this waterway that absorbing large quantity of water while slow down its flow rate and can effectively reduce the impact and the risk of vulnerable element of the rail transit. But at the same time, create interest public space that people can have closer space to interact with water when it's not flood. The example of interjurisdictional and interdisciplinary design on the right is it is actually underneath of a major freeway interchange that has a sunken reservoir that about 7 feet deep, allow for a few acres of land, allow for a large quantity of water reservoirs during the flood, and in non-floods, the space can be used for public. You can even see there is some public art and light. You can see the function can be performed both during the day and the evening. So these are the examples not yet often in this country. By the way, these are a few examples I visited in Rotterdam when I was in Netherlands. But if take a California approach, a system, it will see a tremendous multi-agency, multi-jurisdictional involvement. So it will be wonderful to see if all these agencies come together and supports and promotes interdirectional design innovations, I think we can live in a much broader sense to adapt the climate change, sea level rise, and flooding in a more day-to-day life positive way. In other words, this space can be integrated in a positive aspect of our life. So this is the third element that, as a lifelong architect and designer, I have to focus on, that design aspects, the importance of resiliency. And we expect California American Institute of Architects Resilient Design Committee furthering their work and to explore far more tangible data-based design innovations through multiple disciplines. So these are the three highlighted principal benefit or reasons that BART takes a regional approach. In the actual reality, that we have done quite specific work with different entities to work closely with Caltrans, for example, is one of the projects that lead to, at all levels I had just mentioned, about our responsibility to the region and about that our interest to look at, to promote good design practices for design and construction. So these are the actual tangible work that a transit sector can work with the region to develop a regional scale. And some other accomplishment that BART has achieved in the past few years through with vertically, I call them vertically, with FTAs, FHWAs, and look at how interregional lessons learned or experience can be important to shape our adaptation strategy and policies. So these are some highlights, and I think we, with Norman Wang's presentation, you can see in detail one or two actual works that we have done at BART. This is perhaps a good introduction to Norman's slides here. Is we actually incorporated the consideration for designing against the extreme weather into our overall BART design and construction standards. So they are not siloed. When you develop your capital and deliver capital project, deliver your capital project, consideration and design of and the resiliency is naturally part of it. So that concludes my introductory remarks, and I will stop sharing. And Norman, if you could continue on.
Thanks, Tian. And I know we don't have too much time, excuse me. So if Chad or Stuart, if you could give sort of like a 1 minute, time check or warning, that I would really appreciate that. Okay, let's see. You can see my screen okay? So Tian provided a regional perspective, and I wanted to focus in on some work that we did with our sea level rise resiliency study. It was a grant that we got from Caltrans for $500,000. We started in 2018 and concluded in 2020. And this looked at what were the impacts of sea level rise and flooding on the BART system as a whole, assessing what the risks are, and developing some adaptation responses. So when we were looking at total water elevations, we looked at two scenarios, two time horizons, the year 2050 and year 2090. We had sea level rise projections from the California state guidance for the 1 in 200 occurrence. And then we included the 100-year return storm surge, which based on local literature was 42 inches. So we evaluated a total 65 inches and the 109-inch level. So this is what this looks like at the scenario 1 at 64 inches. The dark blue represents deeper elevations. Lighter blue is shallow, and you can see our alignments and our BART logo represents each of our stations. For reference, for those who aren't familiar, the top left is City and County of San Francisco, and top right is Oakland and City of Alameda. And so there's overlap where we see flooding with our alignment. And then in the scenario 2, it's same areas of flooding, but a lot worse. What's not apparent in these mappings is that we have different types of segments. Some are above grade, some are below grade, and some are at grade. And so those that are those that are above grade, our track and our third rail, for example, are safe, but we still have assets that we keep at grade, such as like our traction power substations, as well as train control rooms and things like that. In our risk assessment, we were able to evaluate and leverage our asset management inventory data. We had a lot of asset replacement cost information from there. And so we were able to draw a lot of information there. For those who, transit agencies, who are looking to do some similar work, I would definitely advise looking at your asset management program for information. So this is a depth damage curve, and what it shows is at certain flood elevations, what is the potential replacement cost damage that we could encounter. And so no surprise, higher elevations is going to result in more damage, and we estimate order of magnitude in terms of asset damage of hundreds of millions of dollars. So it's a pretty big number. And this is just BART asset costs. It doesn't account for, this excludes economic costs, which can be even greater. And when we were looking at some numbers, we were looking at regional wage losses because of delays or shutdowns of the BART system. And we estimated that for pre-pandemic to be $10 to $15 million per weekday. So, this really huge impact on the region. This is titled Embarcadero takeaways, but a lot of these takeaways really apply to all of their site locations. Kind of no surprise, electrical and mechanical equipment doesn't mix well with water. And a lot of our assets are, electrical and mechanical related. Specifically for Embarcadero, it is an underground station. And so we have found that the vents associated with that site, the flooding that would go down goes directly to our track level. And so those are some issues that we need to address. And then we talked about, I mentioned repair time a little bit, I think. We didn't really have historical information for the level of catastrophic event that we were sort of studying. And so when we were talking with, New York MTA about their experiences with Sandy, they had indicated that it could take, depending on the equipment, or severity, from days to potentially up to months for recovery time. And something that's different from BART relative to New York MTA is we don't have a lot of redundancy in our system. Like we can't, for example, shut down a segment and and not be disconnected from other parts of our system. So we don't have that duplicity.
3-minute warning.
Okay, thank you. So, so really quickly, I wanted to share some photos of some vulnerability points, or points of entries is what we call it. These are some photos of the Embarcadero station. The top right is a vent that's in the middle of the street. And so there's a lot of challenges in trying to adapt, because if we try to, elevate this vent, then the street's basically inoperable. The bottom shows an example of one of our station entrances. It's, pretty exposed all around. There's like a small lip about maybe 6 inches to a foot, but, that's not really a lot to help us, deal with the level of flooding that we can anticipate in the next 50 to 100 years. So these were some adaptations, site level adaptations that we explored. There are some deployable measures like these flood shields here, and some deployable vent covers on the top right. Some issues, some caveats with these is that, we have to have places where we can easily store them and retrieve them close by to where we want to deploy them, as well as having some training associated with, how to actually set them up. There are some permanent type of solutions like automatic flood shields and flood walls, but these are going to require a little bit more space to be able to do them. And so it really depends on what kind of right of way or easement that we have to be able to implement some of these options. And then we have some like tunnel shields options, and so these are all sort of site level measures. And this is my last slide. So we organized the adaptation measures in 3 kind of bins: protect, accommodate, and retreat. And we've given the challenges and the fact that we're a fixed rail, it's really difficult to try to, relocate and move things around. So accommodating and retreating are really challenging options for us. So, we really need to focus for ourselves, favoring protective types of measures, which are sort of examples that I shared in the previous slide. And then, I would, last note that I would say is parallel to this is the regional adaptation measures that need to occur, shoreline level types of protections that would be, and these would be supplement to those kinds of regional measures, which are, really, really important. Because if you can imagine protecting ourselves, elevating our station, can only do so much. You can elevate a station, for example, but our surrounding community can still be flooded out. So very much we want to focus in parallel on those regional efforts as well. So I'll leave it at that, and thank you guys for your time.
Thank you, Tang and Norman. We will go to Jason. Jason Lee is a project manager, 3 rail programs with the Orange County Transportation Authority. Please welcome Jason.
Give me a second. Hold on. Can you hear me?
Yes, we can see your slide and we can hear you, Jason.
Okay, great. Fantastic. Sorry, I'm trying to get this thing up in the presentation mode. Everybody can see the screen?
Perfect. This is Stuart.
All right, excellent. Hey, good morning, everybody. My name is Jason Lee, Orange County Transportation Authority and the Capital Programs Division. I'm here to present the OC Rail Infrastructure Defense Against Climate Change Study. Next slide. Well, here is the project area shown on the right-hand side. It's primarily from Irvine to the Orange-San Diego County line. It has 25 miles of rail and infrastructure corridor, and this is part of the low sand corridor in the southern Orange County area. And then just to note, we have Amtrak, Metrolink, and freight running through this corridor here. And we also included the Orange County train stations. We have 12 train stations in Orange County as part of the study. So the goal of the study is to look at climate change stressors that could impact rail service, our operation and infrastructure. We study the risks related to climate stressors such as mudslide, flooding, severe weather events, coastal surge, sea level rise. We identify adaptation strategies for the assets based on near term, that's next 5 years, midterm, 10 to 15 years, long term, greater than 15 years, and the risks associated with that, and analyze the life cycle costs for the proposed strategies. And for the train station, we study amenities improvements that will provide passenger comfort due to climate stresses such as extreme heat. Additionally, we also looked at vegetation management strategies to address drought and precipitation at the station. So the study began with a system-wide exposure scan of the potential climate stressors, and this included high heat, wildfire, drought, coastal flooding, and inland flooding. So out of the exposure scan, we identified 3 areas for detailed study, and that's the coastal alignment and the Mission Viejo Trench, part of the Oso Creek tributary, and the passenger rail stations. So here's the overview of our coastal rail corridor that's owned by FCTA. As you can see on the left-hand side, it's City Dana Point. To the right-hand side, we have the City San Clemente as approximately a 7-mile stretch of coastal rail. The study analyzed sea level rise based on California's Ocean Protection Council and a sea level rise guidance document. So this graph over here shows the projected sea level rise in feet in increments of decade through the year 2100 for each of these scenarios. So these are classified as low, medium, high, and extreme, and it's based on greenhouse gas emissions projected by the state. The chance of occurrence for each scenario ranges from the low end, 17% chance, to less than 0.5% chance on an extreme case. And it ranges from 2.5 feet all the way to about a little over 10 feet. So this next graph shows the existing rail elevation in red. That's over here. And that's overlaid with various scenarios in a storm event, with kind of the light blue showing a 100-year storm event and a gray showing a 500-year storm event. And you can see there are some locations where the storm events will overtop the rail. And here's a picture showing an example of that in a storm surge. So this graph shows a projected low sea level rise scenario with storm surge. So the same color representation, with red being the top of rail and gray being the 500-year storm event. But this one is coupled with the low sea level rise scenario. It's the combination of the projected sea level rise plus storm surge. So you can see there are areas where it will be overwhelmed in a case like that, even in a low scenario. And again, this is year 2100. So just backtrack due to time constraints, we do have other scenarios plotted out, but I was just showing an example of the low sea level rise scenario coupled with storm surge. So we have some vulnerabilities within the coastal rail alignment, and we have developed some flexible adaptation options for consideration. The first one is the baseline revetment. You can see the picture on the left-hand side, showing existing riprap or revetment that's against the railroad here. And the proposal is to continue to maintain this and then with higher crests as needed. So that's one option. And then the improved revetment will put it at a gentler slope with higher, heavier rock size and a higher crest as needed. You can see on the right-hand side, this is the existing standard that Metrolink uses for revetment against the coast. So the third option we have is to improve the revetment with a seawall to protect against projected sea level rise and the storm surge. As I mentioned earlier, the option 2 shows an improved revetment, and essentially what we're seeing here, if you see the smaller black circles, this is along with the purple circles, this is kind of the more like the existing revetment. We're adding kind of the larger size rocks. These are up to 10 tons or greater. This is really going to keep it stable and be able to handle the impact of the waves and the surges that we're anticipating. And this is at a gentler slope at 3 to 2. And you can see the relative elevation is about 25 feet above sea level, and then as well as the proposed seawall in the back of that. So another 5 feet above that. And we're proposing panels that can be adjusted based on future needs. So we don't have to build a very tall seawall. This could be added as needed. And I want to point out options 1 to 3 we just discussed will likely protect the rail from low, medium, and high sea level rise scenarios through 2100. And then it's more cost effective to use options 2 and 3. And I'll show you that in a few slides further down. Option 4, we looked at relocation of the railway from the coastline. So here's a representation of a concept and costs, really shown in red, a realignment of the railroad away from the coast. And this concept is based on a 2004 low-SAM programmatic EIR EIS by Caltrans. And this alternative is called the San Clemente long 2-segment tunnel. And it's a double tracking option with a station in San Clemente. And this will be followed along Interstate 5 from San Juan Capistrano on one end all the way to San Onofre Beach on the other end. So this is approximately 9.6 miles. And a rough estimate based on the study from 2004 and escalated for current costs and inflation, we're looking at about $5.2 billion for this option. So with all these options, we looked at kind of life cycle costs, kind of give us the analysis of what we need to know as the most cost-effective solution that we could recommend. So review the develop options. You can see the title based on each of the scenario, low, medium, and high and then the options having baseline, improve revetment, and with seawall, and ultimately the relocation. And to point out the costliest option is the relocation option, and followed by the baseline revetment option. And the baseline is more costly because the revetment or the riprap size is generally smaller, and with the ocean waves are generally carrying those out, and we're losing the rocks regularly, and there's more ongoing maintenance to keep up with that. Whereas the improved version with the larger riprap size, heavier, will protect our corridor better. So here are the adaptation strategy and next steps. So we'll continue to coordinate with Metrolink, which is our own operator and maintainer of the rail corridor, to maintain the existing revetment based on their standards, and then further study our coastal bridges and culverts to assess for capacity issues and replacement needs. And we will plan for short and long-term solutions using adaptation triggers to support corridor-wide decision-making. So some of the triggers will require a couple of the following points to make. We'll monitor regularly on the conditions, how it changes over time. the observed data from tidal gauges or storm events. And as the future projection changes over time, so some of the based on the data that we have will change as well. We'll implement a solution based on where it's needed, and then performance conditions not met, we'll go ahead and implement solutions such as the improved equipment or seawall options. The next area concerns Mission Viejo Trench. This is an overview of the area where our corridor is mostly in a trench, it's about 5 miles, and it concerns the erosion and flooding due to the adjacent creek and developments. We study future heavy precipitation projections and model for the 100-year flood level depths, and under all scenarios is contained within the creek itself, so we're not worried, as the study showed. So here are some slope erosion concerns in Mission Viejo Trench, and one of the primary mitigation is to provide some V and U ditches along the slope to help water flow and capture the sediment from the top of the slope. And the other areas of concern, shotcrete could be used as a most cost-effective solution, control the erosion. And these strategies will be looked at with a next project that we're currently planning to form drainage and slope stabilization. The study also prioritized stations needing amenity updates based on first and last mile, ridership, future population, and the number of projected height heat events through mid-century. And then with some of these analysis, we have some near-term stations that we may want to make improvements on Buena Park, Anaheim, Tustin, Logan and Gale, and then some long-term stations. And then some of the strategies could be included when a station is being renovated or remodeled, and in that sense, as it could be additional seating and shade structures, upgrade or add hydration stations, change landscaping type. In Southern California, we have lots of palm trees, which doesn't provide a lot of shade. That could be replaced with some shade trees. Also drought tolerant species and drip irrigation. These are some of the things we could consider, and as part of the future station modification projects. So it was a challenge to engage our community during the pandemic with reduced rail service and stay-at-home orders. So we're able to utilize the online services through Twitter and Facebook. We're able to post ads and then basically attain feedback through that mechanism. We also partner with Metrolink in using e-blast mechanism through a database of all the riders in the region. We have fact sheets in multiple languages that represents the community. So overall, we have more than 770 web views. We receive 1,300 English and 76 Spanish surveys, and mostly based on amenities that could improve ridership or our customer comfort. Well, this concludes my presentation, and I'm ready for any questions. I'll turn it back over to you.
Thank you, Jason. And we have Jennifer. And Jennifer is the statewide coordinator with the Florida Department of Transportation, Office of Policy Planning. She has over 20 years of experience in planning, public engagement, land use and transportation, resiliency, and environmental stewardship. Welcome, Jennifer.
Thank you. Can y'all hear me?
Yes.
All right, great. Well, I appreciate the opportunity today to give you a little bit of an overview of how we're working at the Florida Department of Transportation to ensure resiliency of our state's transportation system. So I'm going to give you a brief overview of what we're doing and talk a little bit about how we're linking transit into our resiliency efforts. So first, I wanted to start with some of our planning efforts. We have a number of statewide planning efforts going on that incorporate resiliency. And first of all, our Florida Transportation Plan is our single overarching plan for Florida's transportation system. And it was created by the Department of Transportation with all of our partner agencies. And so it's not just for Florida DOT, but it's for the whole state. And it has a goal in there to call for agile, resilient, and quality transportation infrastructure. So as a result, resiliency strategies and actions are woven throughout this plan, which is newly updated, and we're currently working on the implementation section of that plan. Resilience turned out to be a cross-cutting topic throughout our Florida Transportation Plan update. And then we have also incorporated resiliency into a number of other statewide plans, including our Transportation Asset Management Plan, our Freight Mobility and Trade Plan, and we're incorporating it into other plans as well, one of which I'll talk about a little more in a moment. At Florida DOT, we have something called the Vital Few that builds on the Florida Transportation Plan and focuses on improving safety, enhancing mobility, inspiring innovation, and fostering talent. And these core areas are at the forefront of everything we do at Florida DOT. And resiliency considerations are critical to the implementation of our Vital Few strategies. We have approved a resiliency policy at the department for our state transportation infrastructure. And we've defined resiliency as the ability to adapt to changing conditions and prepare for, withstand, and recover from disruption. We are focusing in our implementation at this time on risks, particularly related to storms, so storm surge and wind, flooding, rainfall flooding, and sea level rise. So our policy directs us to assess the impacts and to employ strategies to avoid, mitigate, and eliminate those impacts. And we're implementing this policy throughout all of our business processes at the department. Collaboration is a key strategy in all of the work that we do at the department, and resilience is one of those as well. So collaboration is key in our process from long range planning all the way through design, construction, operations, and maintenance. So I want to talk a little bit about some things we're doing on implementation. And one of those areas is our strategic intermodal system. And in Florida, our strategic intermodal system is our statewide network of high priority transportation facilities that represent the state's primary means for moving people and freight between Florida's regions, as well as between Florida and other states and nations. So we have a policy plan for our strategic intermodal system that is being currently updated and includes reducing vulnerability of our infrastructure to a wide range of hazards, including extreme weather, sea level rise, and coastal and inland flooding, wildfires, and extreme heat. We also have done an extensive resiliency study for our strategic intermodal system, looking at these various hazards, and have a action plan that is under development for that system specifically. We've also identified in our engineering and operations a number of ways that our design for our transportation system is already resilient. And you see on this slide a number of the ways that we have incorporated, or the number of areas where we've incorporated resiliency already. As you can imagine, we've been dealing with a lot of these hazards for many years and have adapted our designs already. We are always looking for ways to incorporate new ideas and are currently updating some of our manuals to incorporate some new guidance. And we will continue to do that as well. I wanted to show a couple of our innovative solutions that we have implemented. This is some photos from Miami Beach, where we have partnered with the city of Miami Beach on the design and construction of this flood mitigation project that includes connecting with side streets, some additional piping and pump station, and raising the roadway and seawall, using some additional innovative materials in this project. And then another innovative solution that we're currently working on and are very excited about is incorporating living shorelines into our projects where it's appropriate and where we can balance environmental protection or enhance environmental protection while also protecting and increasing the resiliency of the transportation system. Some of the research, since this is our Transit Research to Practice Symposium, we have a number of resiliency research projects going on at the department. I wanted to mention a couple here related to our materials. Our state materials office is doing some research on resilience of asphalt and rigid pavements to flooding and sea level rise. And this is important to transit because as y'all know, at least buses and some of the transit features run on those same systems. So to the extent that we can increase the resiliency of our materials, that will help with transit. We also have a number of other research projects going on. One of them is looking at vulnerable populations and how the transportation affects them in evacuation and recovery from hurricane response. And since transit is part of that, I think that research project will also affect the transit system and the needs as well. So I did want to cover a couple slides about how we're thinking about transit and resiliency and how they interact. And as you can imagine, public transportation is key to resiliency. It does provide alternative means of transportation and transportation choices, and it does support community resiliency, especially for those populations who depend on transit for mobility needs. And as one of the ways we're implementing that is when we have evacuations, our department coordinates with the Florida Division of Emergency Management on supporting local emergency response efforts, and local transit agencies are key partners during an evacuation. As you can imagine, they assist in transporting people during mandatory evacuations to shelters or to other regions or safer parts of the community. Some agencies will adjust their route network to provide more coverage, and others will sometimes increase frequency during these events. And it's all coordinated with our local emergency managers and our state emergency management. FDOT is a key partner with the Division of Emergency Management on that. Transit obviously plays a role in greenhouse gas emissions and reductions. The study from FTA shows that public transportation has significantly lower greenhouse gas emissions per passenger mile than private vehicles. And many transit fleets are also converting to alternative fuels that emit lower greenhouse gases. There are a number of issues that are important to transit, but also are important to the rest of our transportation system as well. So incorporating transit assets and systems into planning for all the extreme weather impacts and disruptions. As I mentioned earlier, the buses and other transit use the same right-of-ways, and so experience a lot of the same disruptions. And incorporating resiliency into transit asset management can also improve resiliency of transit. And then another thing that might not be evident is transit riders are disproportionately at risk, sometimes due to extreme heat. So looking at weatherization and shelters and providing cooling to improve public health in those situations. And then looking at investments to enhance system resilience while balancing existing needs. So looking at balancing state of good repair, system expansion, and incorporating resiliency efforts as well. We have identified a few transit specific resiliency needs. So looking at how to incorporate risk assessment into transit asset management, planning, separate from our transportation asset management planning, how to employ metrics and criticality into identifying vulnerable transit and public transportation assets alongside with other modes, how to balance those, and then also continuing to look at the role of transit and emergency management. And finally, in Florida DOT, we're really all about our communities and helping our communities within the state. And so transit is key in community resilience, providing access to jobs, education, healthcare, food, and other services. And so the extent that to which we can make our transit systems more resilient, that's going to continue to help our communities prosper. We always add a safety message to our slides. So everyone, please make sure you're stopping in an appropriate place at rail lines to stay safe. So thank you.
Thank you, Jennifer. And I also wanted to thank our other speakers. That would be Chen, Norman, Jason, and some of the notes that I took were I really appreciated BART's presentation on, you can protect the system all you want, but if you don't work with your partners, the damages and the sea level rise is going to come to you. So I really appreciated the interjurisdictional view that they looked. And then in BART's case, they can't move the track. And then it kind of went on to Jason's presentation where they're actually looking at moving the track, but it's going to be expensive. And then he also touched on how hard it's been during the pandemic to do community engagement, but they did outreach with the community through social media mechanisms. And finally, with Jennifer, I was struck how comprehensive Florida DOT looks in terms of their projects benefiting their community and within different communities, as well as all the other people that are coming in from different states and other countries. And then finally, some really innovative techniques in terms of adaptation to deal with flooding, living shoreline, win-win for protecting the infrastructure as well as protecting the environment, how key transit is with regards to emergency management, and that it really is a lifeline for residents, for jobs, education, and food. So again, I wanted to thank everybody. It's been a great presentation, and I wanted to turn this back over to Mr. Chad Riding.
Okay, thank you, Stuart. And thank you, Jennifer, Norman, Tian, and Jason. Really appreciated your presentations about climate change resiliency. We are going to go on a break now. It is 20 minutes. And so we will return back at 11:30 Pacific, 2:30 Eastern. So enjoy your break. And again, thank you very much to our speakers at this session, and of course to our moderator, Stuart Morey. Welcome to the session on New Futures in Rail. Thank you so much for joining us today via YouTube. Joining us on our web feed, we have Jim Allison from Capital Corridor Joint Powers Authority. We have Adrian Scher from the Brightline Company. We have Rory Vaughn from Southern California Regional Rail Authority, or Metrolink, as the service is called. And then we have Eric Peterson, who is an independent researcher affiliated with the Mineta Institute. So again, thank you so much for joining us. I'll give a brief bio. Rory Vaughn is a 6-year veteran of Metrolink, the Southern California Regional Rail Authority. Metrolink provides regional rail service throughout the Southern California area. And he is currently the manager of planning at Metrolink. Previously to Metrolink, he has 10 years experience with the Disney Corporation. Eric Peterson is a transportation policy advisor, currently addressing infrastructure funding and finance, public transportation, and intercity and high-speed passenger rail issues. Eric is a former Deputy Undersecretary for Travel and Tourism at the U.S. Department of Commerce and a former Executive Director at the U.S. Consumer Product Safety Commission. He also served for many years on the Arlington County, Virginia Economic Development Commission, where he was chairman of its Tourism Committee and chairman of the Metropolitan Washington Airport Authority's Advisory Board. An active member of the Transportation Research Board, Intercity and High-Speed Rail Committee, and the American Public Transportation Association's Intercity and High-Speed Passenger Rail Committee, and is the publisher of the committee's newsletter, Speedlines. He is the immediate past president of the Washington chapter of the Transportation Research Forum. Adrian Scher is responsible for overseeing the design and engineering of the rail system, maintenance depot, and related rail infrastructure of the Brightline West Line. Mr. Scher is a 30-year transit veteran who previously worked at Brightline, Florida, overseeing the engineering, construction management, and final delivery of the Miami to West Palm Beach segment, as well as the engineering and environmental work of the West Palm Beach to Orlando segment for rail infrastructure. He is a professional engineer in Florida and previously served as the chair of the Transportation Committee of the Florida Institute of Consulting Engineers. And finally, Jim Allison has been with the Capital Corridor Joint Powers Authority since October 2000. Capital Corridor Joint Powers Authority is a management entity for the intercity passenger rail service operating in Northern California. Mr. Allison is the manager of planning for new capital service projects, grant submissions, and phases of project development in the context of the Capital Corridor route, but also at the Northern California mega regional rail network level. In addition to traditional railway project planning and some work in moving towards more sustainable fuels and improved bicycle access for passenger rail, Mr. Allison has been involved in technology-forward implementation projects in passenger rail, including on-train Wi-Fi, on and off-board information systems, and most recently, travel integration, trip planning and payments, working with the state of California. So welcome to this panel session on the new futures in rail. For those of you in the audience, if you have any questions for our panelists, they are certainly welcome. You can contact me through the YouTube comments feed. You can also send me an email at chad.writing@dot.ca.gov. So, starting off with some general questions for the panel. One of the main things that many people who are in the rail industry have noticed is that there has been a renewed interest in rail in the United States. To what do you attribute this renewed interest?
Respond to that question. I think that number one, there is a crying need for more transportation alternatives than just relying on the automobile and the airplane. And research has shown that particularly in distances 100 to maybe 300 miles, intercity passenger rail is particularly attractive. And if we evolve to the point where we have high-speed rail, it's especially attractive. But in terms of reaching parts of the country that are isolated or not have really robust transportation systems, long-distance Amtrak trains, for example, are very they're very attractive, and the population that uses them is a growing part of the voting public. As well, initiatives like Brightline, like Texas Central, like the Cascadia project, and like the California High-Speed Rail project have all generated a lot of curiosity and interest. And for those who have taken advantage of services, for example, like Brightline, has confirmed their perspective, the viability and sustainability of passenger rail. Plus, we've had now over 10 years of effort on the part of the federal government, especially starting with President Bush, then President Obama, and now President Biden, where considerable investment has been made by the federal government in improving not only passenger rail but also helping to improve freight rail. So all of these efforts contribute, I think, to a heightened interest and a higher level of support for passenger rail.
Thanks, Eric. Yes, Adrian, please.
I add in a couple of other points. I agree with all of those, and they're spot on. And certainly in terms of what we're trying to do with Brightline, it is that it's offer an alternative, and people are tired of sitting in traffic. And you know, our primary goal here is to offer people an alternative to be able to have more confidence in arriving on time and having a better experience with their commute and a more productive experience with their commute back and forth. I think there's also, you know, a climate change aspect to this, is that whichever way you look at it, traveling by train compared to other modes is cleaner, and you know, that it means a lot to a lot of us in the industry, and just it's clearly an important theme. And I think there's also a generational aspect. Is I know when I was growing up, I couldn't wait to get in the car, and I think, you know, I look at my kids and they're just as happy to sit and text and be entertained rather than worrying about driving a car around. So I think all those things are contributing to the allure of rail.
Absolutely. And a lot of the points that Eric and Adrian, you bring up about rail, the generational aspect, the climate change aspect, those definitely translate into a different clientele than in the past. And of course, in order to attract that clientele, you do need a different way to advertise. The joint powers authorities that run rail in California, as well as the regional rail services such as Metrolink, do invest a lot of money in advertising. And so my question, kind of geared towards Jim and Rory, is how do you take that, given the changing demographics, the changing focus of rail, how do you translate that into your outreach and advertising efforts?
Sure, that's a great question. I think since I've been at Capitol Corridor, we've seen a massive shift towards using social media. That's probably the biggest shift. It's also quite cost effective. I remember we did put billboards out as you were on a highway that was very congested. You had plenty of time to read that billboard and learn about the Capitol Corridor that was whizzing past you. But I think increasingly we're not looking at the print media as much. It's definitely more online with search engines, people looking for alternatives, and there's other initiatives that involve word of mouth now through social media. And so it's very important that we provide a good customer experience as best as we can, because that still turns out to be the best advertising platform of all, is a good recommendation.
And to add to that, something that we've been finding is that often the best way to get someone to try is to just get them on board and get them to try it. And there's lots of barriers to that. And so tactics that help people overcome that first step have proven helpful, whether it's trial ride programs, special events, promotions, etc. And very often, once someone gets on the train, we find that our best advertising are the other passengers on the train who tell the rider about all the things that they like about it. And if something goes wrong, they can help explain why they still ride and why it's still worth it. And that's proven to be very effective, we think.
And and you bring up some really good points about the word of mouth and taking the traveler's perspective. One of the things about the traveler's perspective is viewing the transportation system as a whole, in that they may, ride the Bright Line somewhere, but they may often take a bus or light rail or something to reach that, the rail system. And viewing it as a whole transportation system, that obviously means you have to work with partner agencies, with cities, if there's a park and ride, working with transit agencies to make sure that there's connections there. Taking both, we have Adrian from Brightline, and then we have representatives of the public sector. How I'm interested in hearing how the public sector versus a private sector, how those partnerships may be different, or perhaps they aren't different at all. So how are those partnerships really manifesting themselves in rail service?
So yeah, I'm happy to touch on that from Brightline. So for us, I was involved with the Florida project, and it is absolutely a key component of making sure the system was going to be successful, is that connectivity that we would have. So our Miami Central station, for example, is immediately next to both Metro Rail and a local people mover in Miami. We've got connectivity to a local transit in Fort Lauderdale and in West Palm Beach, and then in Orlando that we're now extending to. We're in the airport. So intermodality and connecting to other modes is central to what we do. And then out here on the Vegas to Southern California project, a major thrust in us extending our project, which was initially going just to Victorville, Apple Valley in the high desert of California, we're now going down to Rancho Cucamonga, and that's a super exciting opportunity that others on this panel can contribute to as well, but we're tying into the Metrolink system there. It's also a place where the Elon Musk Boring Company is looking at potentially connecting from Ontario Airport, which is only 3 miles away. So you have this really exciting opportunity of having Metrolink, local transit from the city of Rancho Cucamonga, and high-speed rail service all coming together in one location. So absolutely believe in that.
Yeah,
Please go ahead.
There's a number of things in California going on with that, and that's early on we started transit transfers, which were free transfers from conductor on the train to transfer to that local transit service. So we had a lot of agreements and so forth with all the transit partners along the way. That's pretty labor intensive. It's very, you got to go inch by inch, and as you look at your mileage here, you're going to touch a lot of transit agencies. So you want to offer that complete experience. Where we're going to now, and I think is a really important initiative in California, is the California Integrated Travel Project. And that's a way to use standards, standard payments, standards of data, trip planning standards, and then also being able to use standards of applying equity for eligibility for discounts, like senior discounts or what have you, with the state playing a role in that. And we're a part of this effort to standardize things and give support so that data that's available to the public that are trying to plan a trip, they see the transit trips, all the links of the transit trip available in their app or on their Google Transit or whatever they're looking at. The next step is being able to pay for that, or removing the barriers to pay for that, and just make it so you can use your contactless credit card. And that's how you make travel easier for the public. And certainly those connections are really important that we're just talked about, that Brightline's looking at. You need those physical proximity, but then you also need to make it easy to use on top of that.
And that point about making things easy and simple for our riders is really critical. Just given the nature of the space, it can be very complicated to choose to ride and then to navigate the rail network. And And that is I think, one of the big barriers to people riding the service. And so these tactics and strategies that help make it easy for people to choose to ride and help remove their fears and their worries about making those transfers is helpful. So similarly, we have transfer arrangements with effectively all the local transit operators we connect to in Southern California, where you can just flash your ticket and board, or scan your ticket at a QR code reader if they have that, and make that effective transfer. And then for longer distance travels, we've had some success with through ticketing arrangements, where you can say buy a ticket on Metrolink that then also allows you to travel through to someone else's service to, say, LAX airport.
I think that that's probably one of the features like this are one of the great forces that have helped to accelerate public in intercity passenger rail. Think back about how passenger rail was operated back in the 50s, 60s, 70s, and even up through the early 80s. There was no real interest in serving the customer. The interest was in running trains. And somehow there has been this incredible paradigm shift where intercity and commuter rail operators recognize that they have to be customer facing, and they have to be responsive and sensitive to the needs and desires and interests of the customer. And that's helped foster a lot of what we're talking about here today. And it's really the impetus for the California Integrated, which I think is many ways historic and a landmark effort on the part of California. It really sets California apart from most other states. I don't know of another state that has that kind of an initiative going on at the present time. There are vestiges of it through organizations like Brightline. There's the expectation that there will be that kind of an orientation with regard to the Texas project. And what's happening at Amtrak now today is like night and day from how Amtrak used to operate. So these are all very critical changes. They're all focused on the customer and ensuring that the customer has the best ride and the easiest time getting from point A to B, and that their connections are addressed, their payment systems are addressed. They know they can rely on the services being provided.
And you bring up some a good point, Eric, is things are varied around the country in terms of, some states have taken a different route towards rail transit. You recently completed a project called A Model for Integrating Rail Services with Other Transportation Modalities, Identifying Best Practices and Gaps for California's Next State Rail Plan. You looked at basically all the rail plans throughout the country. So you identified in that report those things that most contribute to successes in rail. Could you share some of those top-line conclusions with us?
Well, this was an effort undertaken under the auspices of the Transportation Institute on behalf of Caltrans. And Chad, as you indicated, we not only looked at the FRA guidance for state rail plans, but we reviewed the rail plans of all those states that had plans on record with the FAA as of June 2020. And then we attempted to both identify the best practices as well as the gaps that were present in those plans. We came up with 10 recommendations as a result of our effort. The first was that there needs to be metrics that establish track record or demonstrate a track record of progress from one plan to the next. We believe very strongly that resilience has to be a part of whatever program a plan puts forward to ensure that not only is there infrastructure resilience, but there's a program for asset management and the maintenance of the state of good repair. We looked at the similarities between how the interstate highway system was evolved and the amount of public support that was generated through that effort. And we believe that there are many efforts, many parts of that experience that could resonate with the passenger rail system in the United States, and that rail operators and developers really ought to take a look at what those lessons were and follow them as well. We recommended that a more robust use of innovating funding and financing be utilized, so that it's not just a matter of whatever the federal government will put on the table or whatever the state can afford to put on the table, but that there are a whole variety of other financial tools out there, including public-private partnerships, private activity bonds, and all kinds of other instruments that could be widely utilized to help develop and support intercity passenger rail. We felt very strongly that there needs to be a better framework for determining what the future performance of systems will be, and that just like the recommendation for establishing matrix, there ought to be a demonstrable element to this that will consider performance, economic growth, sustainability, technological advancement, energy sources, climate, and resilience. Then we also found that in the requirements under PREA, there were state and regional advisory boards requested. And very few states have actually done that to date. And those states that have in fact done it, like California, like Virginia, they have been able to provide a level of assurance to the public that whatever the program is either being followed and succeeding, or that it's being scrutinized and proper oversight is being applied.
And I think, Eric, you bring up a lot of really good points from some of the main conclusions about your report. Wanted to kind of focus that, and you mentioned a lot of innovation and integrating a lot of new programs into state programs. I'm curious from Brightline's perspective. So Brightline West that you're heading up, Adrian, is a innovative project, not a whole lot of true high-speed rail in the United States. What new systems or technologies will Brightline West be incorporating, and what was that decision-making process like, such as research undertaken, et cetera?
Yep. So a key, great question, and a key to allowing what we are going to be doing with Brightline in the Brightline West project, a key to this happening was the Federal Railroad Administration back in late 2018 passed a rulemaking, Tier 3 regulation, putting it in simplistic terms. What it does is it allows for you to bring in a service-proven system that's running somewhere else in the world and bringing it into the U.S. with minimal modifications. So prior to that rulemaking, it was the barriers to getting a regulatory approval were beyond daunting. And so what this new rulemaking does is, and we are following, and it allows us to bring in the European technology in our case. So we are going to take a European signaling system called ETCS, European Train Control System, has never been used in the U.S. before. We are able to bring that in, working with FRA with minimal, no modification to that, because it's already proven and Safety cases have been run in Europe for years and years. It's used throughout Europe, so it's a proven system. We're just taking the components and bringing them here. And the same with our rolling stock. We will bring in a train set that is running throughout Europe, and we know it works with that signaling system as well. So while we'll be innovative in terms of being the first in the U.S., what we're really doing is taking technologies and bringing them in for the first time into the U.S. and getting a system running. And the goal and intent would be that this is a first that can then propagate to other corridors, tie into the California system, and also provide a footprint for a model that could be taken elsewhere.
And that's a really good point that you bring about how taking advantage of research that's been done elsewhere and then applying it to the United States. And that was only be able to done through a FRA rulemaking. Kind of stepping back and looking at some of the integration issues that Eric and Jim, and of course you, Adrian, and Roy brought up. Now the high-speed rail system is being built from Vegas to Southern California. At the same time, California is constructing its own high-speed rail system. And that's, even though it's a few years away from being launched, that's still requiring a lot of on-the-ground coordination. For example, the Capital Corridor, Metrolink are all going to need integrated systems. So kind of looking at that is integrating these different rail systems. What kind of challenges have come up, and what kind of opportunities have you been able to take advantage of in working with these different agencies?
Well, on the Capital Corridor side, since we've been working with the state on the integrated travel project, we're not really physically working with them. We would at different station locations like San Jose Diridon, but I think our important piece was integrating at the customer level in terms of what's the medium of interface. Do you have to buy a particular type of ticket for high-speed rail, or are you going to be able to use your credit card and you just kind of keep tapping through and making your payments and it will show up on the bank account? So there's this commonality of trip planning and payments that I think that's where we're focusing on, and certainly the state is communicating kind of with itself. CalSTA is communicating with the High-Speed Rail Authority and their early operator to integrate the thinking and the planning of ticketing so that they can integrate high-speed rail's revenue model with the physical interaction that customers would use. So that's our closest indication. We don't have a really physical connection track-wise per se.
The other aspect, though, of the ITP is a movement towards what has been euphemistically referred to as scheduling, so that when a passenger arrives at a particular place where they may have to change a train or change a mode of transportation, they're met by that other mode in a very reasonable period of time, rather than having to have a layover of several hours before they can move on to their next the next phase of their travel. And I think that's going to be very critical for California. It'll be very critical for improved services Northeast Corridor, and quite frankly, it'll be very critical for the continuance and reliability of even the long distance trains that Amtrak operates.
So our best example of what you're discussing is we are working with a joint power authority that is leading the High Desert Corridor, which is a connection that's planned between Victorville, California, and Palmdale. And the plan would be actually that our Brightline system runs on that corridor out to Palmdale, and then it connects and integrates with California high-speed rail plan. And then also eventually on the other end down in Rancho Cucamonga, there's a vision eventually of on that San Bernardino line of California high-speed rail running. So there is, absolutely a vision of making all these systems connect between Southern California and Vegas and potentially beyond.
And to add to those points, especially Eric's point about kind of that service coordination and the schedule aspect of it, I think one of the great things that's emerged in this industry in the last, or had more of an emphasis in the last maybe 5 years, has been the emphasis on service design. And we've talked a fair bit about the fair side of it and the exciting things that's Jim's leading up north, but also a big proponent of that is the schedule side of it and the service coordination side of it. How do you actually get services to meet each other and make that a good experience and a customer-focused experience? And something that we've been doing, I know others have been doing it as well, and there's been a lot of these schedules going live around the network, around the state in the last maybe year and a half, are what we call pulse schedules, where trains are arriving at regular repeating times throughout the day. And then they're designed to arrive and depart from transfer stations in a consistent manner so that the different services can come in and then head out with that connection working reliably and consistently in whatever hours both of those services are operating in. An example of this we have in LA right now is we launched these kind of schedules in kind of a preliminary way on our San Bernardino and Antelope Valley lines. And those trains arrive in Los Angeles Union Station before the half-hour mark and then after the half-hour mark. And anytime that connection works, or anytime those two trains are operating, they work. And now we're seeing a number of bus operators, LA Metro and others, modifying their bus schedules to align to that pull so those transfers then work throughout the day. And I think that same principle will apply based on our conversations with our rail partners too.
And I remember very clearly, Rory, when we had a Pulse Day, is what we called in California, where we aligned those schedules together. It was a big announcement, and it was really interesting to see how those systems could work together and how those innovations in scheduling design was able to come forth. One thing that I'm curious to hear from the panel is, we've made a lot of strides in rail transportation. And so my question is what kinds of innovations would you like to see going forward?
Obviously, the question of innovation takes many forms. Broader application of technology is one of them, and we've talked about that evolution both in terms of payment systems as well as scheduling systems, as well as the introduction of foreign technology into the United States. There used to be that perspective that it doesn't make any difference what happened in Europe, what happened in China, or whatever happened in Japan. It wasn't invented here, and we've gotten beyond that in a relatively successful. I guess the innovation that we are so eager to see implemented broadly in the United States is improved speed and reliability of passenger rail. We will see it in most vivid form when California project and the Texas project are completed, and in those places where Brightline is able to move ahead with higher speeds than it can presently in Florida. Perhaps that'll happen in the Nevada, California corridor. But beyond that, I don't know about the reliability or actually the viability of things like Hyperloop and MagLab that are being experimented with, and in some places the world MagLab is being used. But that would probably be beyond the traditional steel on wheels, wheel on steel kind of paradigm that we operate now under in the US. That would probably be the most logical next evolution, but I think that's probably decades away.
Yeah, I'll offer maybe slightly different perspective on your question, Chad, which would be I would argue we're the most innovative country in the world. when we have something to apply it to. And the key missing ingredient for us right now is that, you know, we don't have like high-speed rail university, right? Because we don't have a high-speed rail industry. We need a high-speed rail industry in this country so that we've got academia partnering with us in innovating the systems that are in place and just create a whole new generation of people that are growing up, living and breathing in the high-speed rail industry like exists in other parts of the world. And that I think that's what's going to drive innovation in that is if we have a high-speed rail industry in this country, that's what's going to drive innovation and make us the best in the world in high-speed rail, like we tend to be whenever we take over any other industry.
Yeah. I will sort of say that I think the innovation that we can make is working on standards and scale and understanding our role, government role in that. You know, we do have situations where you've got platform height differences because of rolling stock. And I mean, and you're talking about millions of dollars to make sure one station can work for multiple different train systems. And that's sort of that integration piece. If we don't build from those principles, then it is hard to innovate, but it's much easier to innovate when we do apply and recognize the benefits of scale and standards. That's what I'd like to add to that. I completely agree with everything else that's been said. I mean, you feel to your comment there, it almost feels like, Adrian, we're alone in this industry. It doesn't feel like there's a big ecosystem. So that really resonates.
And one thing I'd add to all this, sure, I think we're all innovations and spaces of innovations that I really look forward to seeing advancements in. One thing that's a little bit different that is exciting me from being an operator on the conventional rail network is I think the opportunities that the investment in PTC, positive train control, helps set up. We had for a very long time a rail network and equipment network and all the components of that were either analog or in certain forms digital, but not in the same kind of wired connected way that we now have with PTC. And we have a lot of connectivity and infrastructure in place that one provides all the important mission critical aspects that PTC does, but two, it can serve as a foundation for I think a lot of innovation in how we kind of manage and operate and execute service on the network. And whether that is route optimization, whether that is signaling improvements, affordable signaling improvements such as virtual quasi moving block, whatever it might be. I think the foundation has been laid for a lot of exciting innovations and transformations in that space. And I look forward to seeing those innovations come.
And one of the great potential benefits of PTC is that it helps improve capacity. You can run trains with shorter headways, you can run more of them, and I'm hopeful that at least that aspect of PTC gets utilized and realized.
And those are some really great points you all make about innovation. And one clear thing is that, because our industry is not where we'd like it to be in terms of building up that capacity, supporting that demand, we don't have those academic programs in rail as much as we'd like to. You see parts of it. There are a few universities that have their rail engineering program. Of course, there's ARIMA and other organizations, but having that academia that can engage in that training of new professionals and also engaging in that research. And so in our final question in our last few minutes, I'm curious, what kind of questions do you still have that you'd like to have answered? What kind of research do you think is needed in order to really move the rail industry into the next phase?
A question for us or for your audience?
It's for the panelists, but I know that this is something that we've really wanted to hear more about.
there are two programs that are presently in place that I think set the benchmark at the present time and will continue to improve. One of them is at Meta Transportation Institute, a graduate program in, I believe it's high-speed rail management, and the other is at the University of Illinois in Champaign-Urbana, which has been sort of a landmark, long-standing program, primarily focused on the engineering aspects of rail. I think both of those programs are evolving, and in fact, in April, late March and April of next year, APTA and its High-Speed and Intercity Passenger Rail Committee will host a two-day conference. One of the cornerstones of that conference will be a very robust set of presentations and discussion on the future workforce of the rail industry, and I'm really looking forward to hearing that discussion. We've got, even though we may be small in number at the present time as compared to other industries and other perceived modalities, I think there's a lot more to come and a huge, wonderful future of development ahead of us.
So for us, it's you go ahead, Jim.
Okay, thank you. I would just say locomotive propulsion, energy systems that aren't spewing out the pollutants and the GHG that we are seeing today. So I think that's a very important innovation. The car fleet's getting cleaner, and I know when I put a grant out and I have to do the line of, comparing emissions in the future year, it's not so good unless we get rail on a cleaner system. That'd be my big one. Thank you.
Now, I'll go in the technical weeds for a bit. One of the technologies that we are challenged to get fully flushed out for our project is broken rail detection, which we're required to have. And it's a broken rail detection that's tied into your signaling system. And right now, and this is the case in many things with passenger rail, is we rely on the legacy of freight rails and how they do things. And that isn't necessarily what's right for passenger rail, and particularly when you're building a high-speed rail system. So that's a technology that we're actually, reaching out and talking to companies from around the world and how they've solved that issue, other than track circuits, which is what the freight rail relies on, and therefore has become the FRA legacy comfort place to go to. So that's an area that we're actively looking to see if there's an innovative solution.
Yeah, and one thing I might even add onto what Adrian just said that I'd also love to see in addition to that is detection of track deformation, such as sun kinks and those kind of things, which have long bedeviled the industry for the last few decades. But something that I would also like to see that we don't necessarily need a specialized programs in transit or rail to help us to learn about. So if anyone's from the science school or business school who are listening to this and want to look into this, I'd love to see more research done into the cognitive load that's required to access transit and access a rail network. When customers are thinking about taking our services, what is feeding into that and what is derailing that? There's been a fair amount of effort into this space in the consumer products world, where there's research around, hey, if you have 5 types of mashed potatoes or 2 types of mashed potatoes, you might sell more mashed potatoes if you only have 2 types, because people just I just can't deal with 5. And so we know that the phenomena is a phenomena. And when we talk to people, when we talk to riders or riders who tried and maybe didn't actually go through with it, these reasons come up again and again and again and again and again. But I have almost no quantitative research to help understand that phenomenon in our context. So I'd love to see somebody look into cognitive load involved with taking transit.
And I definitely hope that a lot of these challenges are taken on by the researchers that we have joining us on the YouTube feed. Thank you so much for your time. It was 45 short minutes. I wish we could have gone another 45. There's just so many questions that we have. Thank you again to Adrian Scher, to Eric Peterson, Rory Vaughn, and Jim Allison. Thank you so much for your time and for your very interesting and captivating answers.
Thank you for having us.
And with that, thank you so much. With that, we'll go on to a 15-minute break, after which we'll have Caltrans Director Tokes Omishakin join us for a presentation and question and answer session. Thank you very much. Hello, Director Omishakin.
Hey, Chad. How are you?
Doing well, thank you. Thank you so much for joining us today.
Absolutely, absolutely.
So to give an introduction for the audience, Director Tokes Omishakin was appointed the 33rd Director of the Department of Transportation by Governor Gavin Newsom and sworn in October 2019. Director Omishakin manages a $15 billion budget and a nearly 22,000 employees who oversee 50,000 lane miles of highway, inspect approximately 20,000 bridges, maintain 13,000 state-owned bridges, provide permitting of more than 400 public use airports, fund 3 of Amtrak's busiest intercity rail services, and provide transit support to more than 200 local and regional transit agencies. Director Omishakin's transportation vision for California features a safe, equitable, sustainable, and multimodal transportation system that builds on strong local partnerships. He and the leadership team established the 5 priorities for the department in 2019 and in 2020 finalized a new strategic plan with a focus on Caltrans' foundational principles of equity, climate action, and safety. Born in Knoxville, Tennessee, Omishakin and his wife have 2 children. He is completing a PhD in engineering management from the University of Tennessee, Knoxville, has a master's degree in urban and regional planning from Jackson State University, and a Bachelor of Arts in Engineering Technology from Mississippi Valley State University. So welcome, Director Omishakin, and thank you so much for your message today.
Yeah, thank you, Chad. Appreciate that very kind introduction. And thank you for all the work that you are doing in this space and doing for the department, and in particular in the organizing that you've done to help put this symposium on as well. Very important conversation. So if you could help pull up the slides, and then I'll get us going here. I've got quite a bit of material to cover and share, so I'm gonna zip through it rather quickly because I'd really like to get to hopefully a conversation with everybody before our time. That's the part that I get the most excited about. But to start us off, the conversation that you all have been having, and unfortunately I haven't been able to hear most of the conversation that's occurred, but nevertheless, I believe it's a exciting time to be having this dialogue and to be presenting and talking about issues around transit and issues around equity and climate change. We are very fortunate right now to be in the spaces that we're in, because I can't recall a time in history, and I've only been around transportation for about 20 years. Well, I can't recall a time where the policy ideas together with the resources are lining up as much as they are today, the potential that we have. When you think about the federal level, even post all the challenges we had with COVID and ridership slowly picking back up, the proposals that Congress and the current administration are discussing and debating potentially will double the amount of funding that we have for transit. I mean, that's unheard of for any mode of transportation to within one cycle experience a doubling of the support, financial support that goes to it. And there's also all this talk about policy ideas on equity and of course, climate change. So can be more pumped up about the potential we have to make a difference for here in California, for the people we serve, but also across the country as well. So to get started, next slide. We're going through cultural change around these issues at Caltrans. We have gone through a process where we now have foundational principles. And those and the three foundational principles that we have are equity, climate action, and safety. Meaning essentially that everything we do in the department, all the work we do, everything is done through this lens. When you think about the traditional state DOT and possibly even city DOTs, this is not tipping. These are not typical items or go-to items that decisions get formed through. But that's where we are today. It's not been easy to make a transition like this, but we believe when we do this, when we focus this way, the shift we're making is putting people first. We're becoming a more people-centric organization, people-focused, and not necessarily the delivery of a particular project or an item. It's not about necessarily that bridge or that highway or that transit stop. Those are means to an end. The goal is to have a brighter future for everyone that lives in this state. And if we keep that at the forefront and use these guiding principles, these foundational principles, we believe we will continue to transform this state for the better. Next slide. So as a part of that, those three items being our foundational principles, two key documents that we adopted earlier this year, in February of this year, are number one, our strategic plan, our 5-year outlook strategic plan that outlines internally what we're going to focus on as a department. Every state DOT and most organizations have a strategic plan. Ours has 6 key areas that we're going to focus on. That includes equity, livability, climate action, multimodal transportation, stewardship and efficiency, and cultivating excellence. So embedded in the strategic plan are those 3 foundational principles. And our team at Caltrans, that 22,000 member team, I think it's been off to a great start in adopting this outlook and adopting this vision. I get a chance to travel the state a little bit. I've been on the road, was in San Diego this week, and engaged some staff, and people are excited about this new strategic direction that we have. And also our long-range plan. It's called CTP 2050 in California, done in conjunction with the Transportation Agency and several other partners. We've created our 30-year outlook for transportation. And when you look through that as well, also embedded, very critically embedded in there, are those same foundational principles to guide our decision-making. Now, you can put these plans together, and they look great, as you can see from this graphic, but beyond just putting a great plan together and putting the right words together, we want to live these plans. We don't want these plans just to be great notes and have great talking points. The challenge for us is to constantly check in, to guide ourselves, to check ourselves, to make sure that we're actually living this direction that we are committing ourselves to. Next slide. So as a key part of the equity effort change that we're making as a foundational principle, we've decided to put together a 4 Ps framework. This 4 Ps framework was in an equity statement that we released last year from the department, the first ever time in the history of the department an equity statement was released. But I'll say, as a side note, that even before that equity statement was released last year, and it was post the unrest that we saw last summer, I'll give our department a lot of credit. There's been a lot of focus on issues around equity for years, well before I got here. But I believe we turned it up a notch and got even more honed in and buckled in on this issue last summer. And I couldn't be more proud of some of the steps that we're taking in this space to, again, actually live this commitment. And it's not easy, but we've got to live this and not just talk about it. At high level, people is about our team, our staff, the fact that it should reflect as much as possible through our recruitment, through our hiring, through our promoting, opportunities for people, regardless of their background, their orientation, their gender. It shouldn't matter. We should have a true opportunity for people who work for the department to be able to have success here. Next is projects and programs. This is where I believe we've really faced a reckoning and an awakening to understand the impact of the work that we do on communities. And I think we are understanding that more and more, and we want to change this. Some of the things we've done, we want to engage more genuinely and sincerely communities. And so we've got a lot of growth, room for growth as it relates to projects and programs. Partnerships is about the vast business potential that we have for communities. The fact that we have a $1.1 billion small business budget. There are so many small business in this state that work on either planning related issues or design related issues, contracting, physical construction, that we need to broaden out and make sure that we're truly given an opportunity for business, small business, DBEs to grow through those opportunities at Caltrans. And we're doubling down on this effort within the department. And finally, the Planet P is about the fact that when you look at the impacts, the negative impacts of on the environment, you can tell that there are disparate impacts as it relates to many of the marginalized and underserved communities, and we need to tackle that as well. Next slide. I'm not going to spend much time on this, but before we had a finalized strategic plan, before we had a new long-range plan and the 4 Ps, this is how we started in 2019. These were the 5 priorities that we were able to establish when I came on board to lead the department: safety, modality, innovation, efficiencies, and partnerships. And this work, these priorities help lead us and guide us into the creation of that strategic plan, finalizing that long-range plan, and issues like key areas like the 4 Ps. Next slide. So to hone in on the 3 areas, again, a little bit more on the foundational principles that we're using. There's no doubt that we've got a huge challenge as it relates to safety for California and for the country. For the country, we topped 40,000 people last year, despite the downturn in volume on our roadways and our transportation system. One of the worst years in recent memory, or in recent time, I should say, not memory, but in recent record. And vulnerable users also seen a heavy amount of that negative impact. But overall, in California, 10 people a day die on our transportation system. 50 people a day are seriously injured every single day. That number has to fall. That number has to drop. And we have to focus in on not just vehicles, but the vulnerable users of the system as well. Because for the vulnerable users of the system, that number is nearly 3 out of 10. So nearly 30% out of that 10 a day is coming from people walking, biking, trying to get access to transit. So we've got our work cut out for us here. And I believe in Vision Zero. We believe, as a department, believe in Vision Zero. We're changing policies. We're putting up in place a new policy around Vision Zero that embraces a safe systems approach to addressing the transportation challenges we have. Some people say they're not completely bought into this idea and concept that by 2050, in 30 years, we can get to zero. I believe we can. I believe we can. And part of the reason why is if you look at some of the changes and the growth that's happened in this space nationally, I'm sorry, not nationally, internationally. If you look to Europe, for example, the European Union, if you pull up the data, they've embraced this safe systems approach, the Vision Zero outlook. The EU has seen roughly a 55% drop in fatalities in the last little over a decade, a little over 12 years. 50%, 55%, I believe is the number. They've nearly cutting half the entire fatalities there. If they can do it, and look, I know their land use and their development pattern is different from ours, more modal choices than ours, but I don't think it stops us from still wanting to shoot for growth here, for change here, to save lives in this place. This is our foremost priority as transportation entities, and it will continue to be a big part of the lens that we look through. Next slide. Modality just goes without saying as a priority for us. If we're going to get to the place we want to get to as a state in California, to reduce fatalities, to reduce emissions, to create a better quality of life, both health, economically, this has to be the way we continue to grow our transportation system. Not by widening highways and freeways, but investing in transit, investing in rail and other modes of transportation. And that's the outlook that we're going to have. Not that it means an absolute no to using potential highway widening as a way to improve capacity. That may be a need, but it has to be the absolute last resort, is the approach that we're taking from the state now. Whereas before, anytime we needed to solve a capacity challenge or safety challenge, whatever it was, our go-to was the hammer, and the hammer essentially was let's add a lane, or let's widen the lanes. So it's a different perspective today. Next slide. Cal ITP, I mentioned briefly on the innovation slide, if you recall. Innovation was one of the priorities we have. Cal ITP is one of those cutting edge efforts that we're taking on and leading from Caltrans. There's a lady named Jillian Gillette and Jeannie Ward-Waller on our team at Caltrans, who are leading the way for the state in working to essentially make it easier for people to be able to pay for transit and integrate as much as possible the mobility options in the state, whether it be micro mobility, bus transit, rail transit, to integrate those mobility options and make it easier for people to be able to get from one mode to the next and pay for that particular mode. Really exciting effort. We've got several pilots on the way across the state, and more to come in the next few months. Next slide. Part of the reason why transit and modality in general is a keen area for us to focus on is this particular graphic. There are obviously many other reasons why we should be focused on this, but for us in California, the number is 41%. The base number is 41% for transportation's impact on GHG in the state. If you look more closely or you refine these numbers, that number actually goes up to 50% when you account for fuel and oil production. I think it's like 48.5%. So nearly half of the bad air quality in California comes from the transportation sector. Higher than any other state, higher than Texas, higher than Florida, some of the other larger states, higher than the United States average. The United States average is 29% of the GHG coming from the transportation sector. And you can see industrial pollution on this particular graphic. Industrial pollution is coming in a far second. That's how much work we've got to do. We've got so much more work to do in transportation to improve the air quality. Next slide. Part of that growth for us in improving modality is focusing on efforts around managed lanes. Caltrans has a history of not necessarily being on the forefront of this issue. We are changing that. There are some early planning studies that we're finally getting involved in. This is issues around managed lanes, hot lanes, HOV lanes, mostly have been led by local governments and regional governments in California. But we're stepping up and doing our part to do more in this particular space, because as you can see from this graphic, and I think we know this well already, it overall just improves mobility and many other issues that we're holding ourselves accountable to in the state. So we're going to be doing more. I-5 in Orange County is going to be one of the first efforts that we take on in California, where we're potentially going to be doing a pricing scheme around managed lanes. Next slide. Talked about innovation already, so I'm not going to spend a lot of time here, but I believe California is the innovation capital of the world, and our department should reflect that. The fact that there's just so much happening, and even in the transportation space, beyond the Googles and the Apples and so forth that exist here. This is their headquarters. I'm not sure what's wrong with Mr. Tesla, but they're leaving the state. But from a transportation standpoint, there's so much more. Uber, Lyft, all the big mobility outfits, companies in the world that are big on innovation are right here in California, and we're embracing that innovative culture at Caltrans as well. Next slide. We've been leaders in the CAV space. We've got several people from our team, our staff in our Drizzy office, our research office, who've been involved with the state DMV, who's really been leading the way here. But the issues around connected autonomous vehicle bring so much promise when it comes to mobility, addressing mobility needs, potentially safety needs or safety challenges. And I look forward to our continued growth in this space, but we've got to pay attention to what's happening in this space. And I'm glad that Caltrans has been leading the way for many years on this front, nationally and locally. Next slide. TSMO, I think many of us know already as transportation leaders, everybody listening, how much potential this particular area really has. I think I don't think we've embraced this area enough. There's much more investment that could happen in this space. When you think about the transportation dollars, and if you were to look at the buckets of where money goes to in transportation, whether it be maintenance, construction, etc. When you look at the operations bucket and you look at where the challenge mostly lies when it relates to congestion, you will notice that there's very much a disparity between how much we put into TSMO and what the potential benefit is on the other side for transportation. We could do a lot more in this space, and we're going to be looking to do that in the coming stepping up our game at Caltrans even more, and hopefully nationally as well on the TSMO front that will benefit transit and all other modes in transportation. Next slide. Efficiency is something that we're embracing very much as well. We have a pretty hefty budget within the department. You heard the numbers from Chad earlier. We're probably a little over $16 billion agency now. Most people hear those numbers and they say, oh, you guys just kind of do what you want to do with that money. By no means. We should be looking for as many efforts as possible, like from this graphic, to figure out how to reduce how long it takes to get information back to certain locations and be just overall more efficient in the delivery of our work at the department. So we're embracing that every day at the department. And if you go to the next slide, part of what's being required of us through SB1, the transportation bill that passed in California in 2017, part of what's being asked of us is to identify a way to save like $100 million a year. But overall, that effort that passed in 2017, again called SB1, had a very much a multimodal outlook. Some states who have had revenue bills to pass haven't necessarily had this, and California had a lot of great foresight, I believe, in this state to, as you can see from this graphic, put nearly $1 billion towards multiple modes in this state with that increase in revenue with SB1. And I think it's paying dividends today in the state by some of the work, grant funding that's happening both for transit and bike ped, as you can see from for these numbers. State. Next slide. And I think this may be the last slide. Partnerships is absolutely integral to any success that we will continue to have, all of us, in doing our work in the transportation space. If we're going to be successful, I think the engagement, the genuine, sincere engagement with communities, with businesses, NGOs, has to happen, because this work is not for us. At the end of the day, again, it's for the people we serve. And building true partnerships and having true engagement is not easy. Historically, many organizations like ours have mostly been able to just go about doing the work in a silo and not having that true engagement. But I think if we are going to be truly successful in creating that brighter future for people in our state, we have to have this true level of partnership and engagement, and it's an absolute priority for us at the department. And I believe that may be it. Chad, is there one more slide? Okay, just contact information, a way to reach me. If you need to reach me via email, don't answer phones, so don't waste your time calling me. And just recently joined social media as well, Twitter. So you can connect with me that way. So again, thanks for inviting me. Sorry I rushed through that. It was a lot of information, but Chad, look forward to the Q&A from you or the audience. I'd love to take either one.
Thank you so much, Director Omashakin, for that presentation. Really, really appreciate the insight that you gave onto Caltrans and that your vision for transportation in California. We do have a few questions that came in beforehand. Let me check the feed if any have come in since the presentation began. Nothing that I can find, but we do have many from that came in beforehand. So one question that came in was about the high-speed rail line and about how Caltrans supports the high-speed rail through our projects in many communities, through our intercity passenger rail. And so the question is, how will the existing California passenger rail routes complement the new high-speed rail system?
So I still last part, that question sounded, explain that question one more time. How would a new high-speed rail route complement the high-speed rail route? I wasn't sure.
Exactly, yeah. So how will the existing California passenger rail routes complement the new high-speed rail system?
Well, that's a big part of the vision that went into the high-speed rail project that's moving forward, and the future extensions as well. If you get a chance to look at the maps, the routes that are currently being worked on right now in the Central Valley, and they will eventually connect further south to SoCal, to the LA area. It keeps into consideration both our highway system and the existing passenger rail within the state. So they'll complement one another. I'm just excited about that potential. Again, high-speed rail has faced a few hiccups in the state. The prior federal administration took away some funding from it. The current administration, as many of you know, is doubling down on rail, and the money that both the administration has given back to California and that Governor Newsom is proposing to spend on high-speed rail I think it's going to pay huge dividends for the state, both in regional connectivity and within communities as well. So if you get a chance to look at the map, I don't know who the question came from, but if you get a chance to look at the map, there's a little bit of connectivity between both passenger rail potential. Not right now, not in the Fresno phase that's being built right now, but as it goes south, further south, there'll be some connections there.
Absolutely. Yes. The bridging that gap over the Grapevine down to Southern California is a big goal of transportation in California. So another question is, you've risen to high levels of transportation management and executive leadership, both California, Tennessee, giving you broad experience. What ways do you see for transit researchers, transportation officials, and practitioners to build effective partnerships?
Well, like I said as I was wrapping up, I don't think we can have true success in this space without having real partnerships that are developed and true engagement with the people we serve, but also across the line with other sister entities, if you will, in this space. I just think it's so important when you think about some of the things that we've been challenged with lately in many of the communities we serve. In California, for example, externally, a lot of people think California is a pretty monolithic, monolithic state. Like it's a very homogeneous place. Like, oh yeah, all those folks out there on the West Coast, they just, hug trees all day. Whereas not everybody's completely bought into that outlook. And so for an organization like ours that's statewide, we have to try to understand how people in some parts of Northern California may look at the issues a little bit more differently, or in rural California versus if you're in the Bay or in LA or in San Diego. So, building those partnerships with the people we serve is important. And if that person was referring to sort of in your personal career as well, not just in the work, but personal, besides honing your professional skills with the work that you do, you're really getting better at that. To me, that's the next most important thing you could ever do. Of course, you got to understand what you're doing first and grow in that space. But the very next thing you have to do, if you're looking to advance and grow in that career, is understand how to connect with people. I think it helps along the way for you to be able to make that transition and growth.
Absolutely, yes. Connecting with people is such an important skill. It's something, we should do anyways, but being able to do that at a business and a partnership just is such something that really, I think, is kind of launch people's careers, make things work better, and really drive transportation change.
But by the way, Chad, I say that often, but I like to remind people that we shouldn't do it because you said, I think you just said we should do it anyway, and that can't be. I don't want to miss that highlight you just made, because when you're making those connections and trying to link with people, I don't think you should do it with ulterior motives.
Exactly.
Like, you can't go out there saying, oh yeah, I just want to connect with people just for the sake of connecting with people because I want to advance my career or I'm trying to get something out of them. It's like, as you're doing that, you're trying to figure out, okay, how can I make a difference for this person or this group or this organization? How can I add value to them and help push along their agenda or our joint agendas, whatever, or building just a true friendship. It shouldn't be like, oh yeah, I'm going to do this, and next thing you know, I'm going to move up or whatever. I don't think that works.
Yeah, exactly. It's not transactional.
Exactly.
It shouldn't be transactional. Even though it's weird because such a key to interacting with people, but it has to come from a sincere place.
Absolutely.
We do have something from the audience. It says, how will Caltrans encourage more infill development within the state to limit sprawl? And does sprawl development decrease fire safety? What role will public transit play in it?
That one part of that question really caught my attention. Does sprawl decrease? Say that again.
Yeah. So, how are we encouraging infill development to limit sprawl? And so this person wanted to know how sprawl development might decrease fire safety. But I think maybe we could take the second part of this question where it says, what role will public transit play in limiting sprawl and also helping fire safety, given that, every year for the past several years, we've had major fires that have devastated several communities.
That's a really good point that I haven't even made the connection on lately, but I think it's a very good point about the connection between fire increases in the state and sprawl specifically. When you look at fires in the state, a majority of fires in the state are started by power lines and lightning. And so if you look at the power lines component, power lines falling down, it's because of sprawl that the power lines are in the middle of them. And so the more you decrease that need to put power out further and further, the likelihood is, that's a good point. The likelihood is that you're actually going to potentially, hypothetically, reduce the amount of fires. Look, the challenge in California is huge as it relates to this. I shared yesterday at a public event, for many years, the average has been roughly 500,000 acres burning in California a year on average throughout most of the 20th century. It's 5 times that now in the last few years, 2.5 million acres a year burning in the state. So larger than the state of Connecticut. We're burning the state of Connecticut annually every year, if you can wrap your mind around that. So I think that's a good point about the potential that it serves to, again, think about infill. As far as the transit connection to it, to try to get to that part, there's no doubt that if we try to encourage and push and lean in on TOD will mean, assuming everybody understand, transit-oriented development. The more we're able to do that, the less likely we're going to need to continue to sprawl further and further. Look, California is facing a significant housing shortage in the millions, more than like 3 million units. So part of the challenge has been, and the complaint has been, look, we need development wherever we can. If it's got to be sprawled, it doesn't matter. We need it, but there's so much potential on our major highways, on our major transit, rail, and bus routes already to build rather than going further out, which will again exacerbate the climate challenge even further, the further and further we build out. So very astute question by that person. Thank you.
I know I recently bought a home and houses had offers with them in a day or two and were off the market. It's pretty competitive.
Yeah.
For a final question, this comes from the chat and it says, should the infrastructure bill pass, the one that's at Congress right now, does Caltrans have the staff capacity to apply for, plan, and build projects? If not, what are you doing to develop staff capacity?
That's a pretty common question that I'm starting to get lately. So if IJA passes, we're estimating, rough estimates, is that California will get $2 billion more annually onto our $16 billion budget. And some of that money goes to local government, not all directly to Caltrans. you know, what I'd like to focus on more and more, and I think we're doing it a little bit beyond what I said about people in that framework, you know, about how equitable it needs to be. What I'd like us to do more and more is to talk about and share with people some of the things that I just outlined today. How meaningful this work is when you join a state DOT like ours. How meaningful it is, the potential to impact 40 million people is unlike anything you'll ever get a chance to do. I think it's one of the things that makes us really competitive with, you know, local entities who are, you know, are hiring planners and engineers and geologists and, you know, IT specialists, the whole nine, the whole spectrum of people we need. Here, the level of impact is so much broader. And look at the lens we're doing it through, not just because it's what's hot right now. We've been doing it for a while, and it's something that we're committing ourselves to. But I think we have to compensate better as well. I'll just be honest. We're not the state agencies are not usually the agencies that have the best compensation packages, but I think we're making a lot of headway there. Our administration has been able to support that this year, despite COVID. We've seen some increases, but I think if we can share how our why is so important to California and how we're making such a huge difference through our why, and take care of, provide more resources for the people here, I think we'll be able to recruit that new staff that will help us deliver on that work. But we need more people to get to the question. We don't have the full staff that we need to be able to do the work we have now, and even $2 billion worth of additional work.
And that's a good point, is the recruitment is very difficult right now with, I think, somewhere around, 4 million people quit their jobs, somewhere around 3 to 4% of people quit their jobs last month, just because there's great turnover coming from the pandemic. Thank you so much, Director Omashakin, for your time today to come speak to us. We really appreciate the insight that you bring as a transportation leader, not only in California, but in the nation. And so we're very grateful that you were able to share a lot of where Caltrans is going, and that brings all of transit and rail in the state as well with it.
Absolutely. Thanks, Chad. Great work. Look forward to hearing more about the outcomes from the conference.
Thank you so much, Director.
Yeah.
Now we're going to hear from Dr. Lily Eleftheriadou from the University of Florida, who will give some closing remarks and reflections on this 3-day event.
Good afternoon. Can you hear me okay?
Loud and clear.
Wonderful. I'm gonna share my screen here, and I hope you can see my screen as well. Wonderful. So I have assembled 4 points that I've seen as themes throughout the conference. So I'll start with the first one, which is the evolving role of transit. And our first speaker, Jeff Nelson from Illinois, coined the phrase endless evolution. And I think it's very fitting to the discussions that we've had. If you think about transit, traditionally it's been about fulfilling travel needs and environmental concerns and congestion reduction. But with COVID, it really switched into becoming a lifeline, a service that for essential workers, and it was an essential. It became very apparent early on that how essential transit workers are. And now with the increasing emphasis on accessibility and equity, we're seeing that increasing role of looking at mobility from the perspective of accessibility, and more on that later. During the symposium, there was an excellent session on accessibility and equity, and that covered this a lot more in a lot more detail. The second point that I took away is the importance of partnerships. And this was brought up from our very first speaker all the way to the last one. And, you know, the importance of community engagement. Cleveland Ferguson from JTA mentioned that in his opening remarks. Community engagement is key. And in addition to the community engagement, I would say there's several other types of partnerships that were clear throughout the symposium. And you know, starting with the community engagement, the importance of getting to communities, to cultivating trust, to getting buy-in, to the importance for that buy-in in the resilience for the agency itself, and how agencies like Miami-Dade were able to recover much faster because of that buy-in from the communities. The second one that's also the theme of the symposium was the idea of research to practice. And you know, as an example in Gainesville, and I'm very thankful for the participation of Jesus Gomez, Melissa McCready from Gainesville and the Gainesville RTS system, that we have a very strong partnership to that allows us to understand a lot better what the local problems are, to work with our local partners to develop suitable solutions. And so in my mind, that's an excellent model. And again, very thankful for the partnership with the City of Gainesville and the University of Florida, as well as the Florida Department of Transportation. So this idea that, you know, with advanced technologies, with the digital future of transit, with technologies such as micromobility, how do we integrate all that, and how can we use the tools that are developed through research to implement them and to be able to serve our communities better? So partnerships at multiple levels, federal, state, and so on. Something that I think is also extremely important is the idea of employee empowerment for transit workers. And this was also mentioned, and it's an extremely important component of this idea of partnerships, of engagement, of cultivating trust, especially in this era where it's really difficult to attract workers. And so having that trust, maybe we wouldn't have, you know, 3% of the workforce quitting if we had more of this empowerment, which actually Mr. Cleveland Ferguson from JTA mentioned in his opening remarks. The third topic that has been discussed extensively during the symposium is the idea of social equity, and that really permeates all the discussions. The 2 points that I want to make is, number one is when we have a performance measurement framework, how can we integrate accessibility metrics in addition to efficiency and you know, quantity, quality, capacity, those dimensions of mobility that we're typically looking at, and how can we get to accessibility rather than looking at ridership? How can we evaluate the degree to which a particular community has access to jobs, has access to essential services, and how can we change the way that our performance measurement system works to incorporate that? I think that would go a long way to change the way we're looking at transportation services. The second one is the allocation of resources. And it's, you know, from discussions with, for example, Jesus Gomez from the City of Gainesville, the demand in the City of Gainesville, I'm most familiar with, has grown 5 times, but in the last 5 years, there's no commensurate increase in funding. So how do we look into the allocation of resources so that we can help with growth and sustainability really of the transit community and transit agencies? And the last one I'm going to mention is the sustainability and resilience from many different perspectives. There's electrification mentioned, and many of the agencies are making that push toward electrification. There's also, of course, discussions about climate change and the impacts, and how do transit agencies position themselves to be able to have the resilience that is required for serving communities. And even from the discussions in this last session, we heard about fires. There's, resilience to COVID, there's resilience to hurricanes. How are transit agencies positioning themselves for resilience for their communities, not just resilience for the transit agencies, but for providing this degree of accessibility, which is, I would argue, it's a public good. It's a necessity for society, whether we're talking about productivity, jobs, health, you name it. So in my mind, the transit is an essential component of all that. So those are my 4 points. Excellent discussions, and I know that there's going to be recordings of those available. I urge you to go back and if you haven't, to attend some of these recordings, to view those recordings. And thank you to Chad for an excellent organization and leading the steering committee into a wonderful symposium. Again, my name is Lily Eleftheriadou. I'm the director of the University of Florida Transportation Institute. You can see my email there on the screen, and happy to answer any questions.
I don't know if we have any questions right now, but thank you so much, Dr. Eleftheriadou, for taking out the time to giving us those final remarks. Thank you again to everybody who participated, who helped organize, who helped speak, serve on panels, moderate. Without you, this would not have been possible. It really does take a village to put on a symposium. And thank you so much again. Really appreciate all of your times. So you have a great rest of your Thursday.